Hello there, and welcome to the Scientist Sleepy. Have you ever paused to consider the sheer audacity of our reach, that a fragile whisper, forged by human hands, has journeyed further than any other object we've ever created, venturing into the profound silence between the stars? Tonight, we embark on a quiet, cinematic exploration of Voyager 1, the furthest human object, and its extraordinary voyage into the interstellar medium. So settle in, allow your shoulders to soften, your breath to deepen. If you find comfort in this journey, please consider a gentle like and a subscribe to join our community of quiet wonder. And as we begin, I invite you to share in the comments below. What celestial thought has most recently sparked your curiosity? For in listening to Voyager's tale, we are, in a way, listening to the quiet hum of our own expanding awareness. Let us now drift towards the beginning of this remarkable odyssey. Voyager 1's journey began not with a thunderous roar, but with a precisely orchestrated whisper, a gentle nudge from Earth's gravitational embrace. The launch of Voyager 1 on September 5, 1977, was the culmination of years of meticulous design, rigorous testing, and an audacious dream: to send a piece of humanity, a silent observer, on an unprecedented voyage into the vast unknown. This wasn't a conquest, but an offering, a scientific emissary dispatched to the farthest reaches of our solar system and ultimately beyond. The objective was grand, yet the initial act was deceptively simple: to escape Earth's familiar pull and set a course for the outer giants. The spacecraft, a marvel of engineering, was equipped with instruments designed to taste, see, and hear the cosmos, to gather data that would redefine our understanding of our celestial neighborhood. Its design was robust, built to withstand the harsh realities of space: the vacuum, the extreme temperatures, the relentless bombardment of radiation. Yet beneath its metallic shell lay a profound vulnerability, a dependence on Earth for its initial trajectory and the commands that would guide its destiny. The launch itself was a moment of quiet triumph, a testament to human ingenuity and our insatiable curiosity. As Voyager 1 ascended, it carried with it the hopes and dreams of a planet, a tiny spark of consciousness venturing into the immensity of the universe. It was a carefully calculated departure, a deliberate step away from the familiar warmth of our sun, towards the cold, silent expanse that beckons us to explore. The initial trajectory was crucial, designed to harness the gravitational forces of the planets it would encounter, turning them into cosmic slingshots that would propel it further and faster than any object had gone before. This was not just a journey of distance, but a journey of discovery, a testament to our innate desire to understand our place in the grand cosmic tapestry. The initial moments after launch were a delicate dance between the spacecraft and the intricate ballet of orbital mechanics, a precise alignment of forces that would set the stage for its epic odyssey. It was a beginning, a single, determined pulse of energy sent out into the silent dark, carrying with it the echoes of Earth and the promise of revelations yet to come. The very act of its departure was a philosophical statement, a declaration that humanity, though bound to its home planet, possessed a spirit of exploration that transcended terrestrial limitations. This initial phase, often overlooked in the grandeur of its later achievements, was the foundational act, the quiet genesis of a journey that would forever alter our perspective on the cosmos and our place within it. It was a deliberate act of reaching out, a physical manifestation of our yearning to know what lies beyond the horizon, to touch the untouchable, and to understand the incomprehensible. The Voyager program represented a pivotal moment, a bold leap into the interstellar unknown, initiated by a carefully calculated departure from the only home we have ever known. The initial stages were about setting the correct vector, ensuring that this emissary would have the optimal trajectory to achieve its ambitious goals, a silent promise whispered into the vastness of space. This was the moment when Earth, our cradle, released its precious cargo, allowing it to begin its solitary, yet profoundly connected, journey through the cosmos. The careful planning, the precise calculations, all converged into this singular event, the launch of a probe destined to become humanity's furthest reach, a testament to our unyielding drive to explore the universe. This initial whisper, this gentle push into the void, was the genesis of a journey that would redefine our understanding of the solar system and our place within the grand cosmic narrative, a testament to our enduring curiosity. Voyager 1's initial ascent was a testament to the power of meticulous planning and the elegant application of physics. The trajectory was not a straight line, but a carefully plotted curve designed to maximize its velocity. By utilizing the gravitational fields of the planets it was destined to visit. This concept, known as a gravitational assist or slingshot maneuver, was a stroke of genius, allowing Voyager to gain immense speed without expending precious fuel. Imagine a figure skater pulling in their arms to spin faster. Similarly, by passing close to a massive planet, Voyager could borrow some of its orbital momentum, accelerating it towards its next destination. This technique was not merely about speed. It was about efficiency, about making the most of the cosmic architecture. The launch window itself was a critical factor, a specific alignment of Earth and Jupiter that would provide the optimal gravitational interaction. Missing this window would have meant a significant delay or a completely different, less efficient trajectory. The spacecraft was equipped with a radioisotope thermoelectric generator, RTG, a nuclear battery that would provide power for decades, far longer than solar panels could sustain in the outer solar system. This ensured that Voyager could continue its mission even as it ventured into the dim reaches far from the Sun. The instruments aboard Voyager were state-of-the-art for their time, designed to study planetary atmospheres, magnetic fields, and the composition of their moons. Cameras, spectrometers, magnetometers, and particle detectors were all packed into this relatively small probe, ready to capture the secrets of the outer planets. The primary mission was to explore Jupiter and Saturn, but the spacecraft's design and the fortunate alignment of the outer planets allowed for an extended mission, a grand tour that would take it far beyond its initial objectives. The launch vehicle, a Titan IIIE Centaur rocket, provided the initial powerful boost, propelling Voyager out of Earth's atmosphere and onto its interplanetary path. The early days of the mission were a period of intense monitoring and system checks, ensuring that all instruments were functioning correctly and that the spacecraft was on its intended course. The communication from Earth, a faint whisper across millions of miles, was crucial for guiding and controlling Voyager. The Deep Space Network, a global system of radio antennas, played a vital role in maintaining contact with the spacecraft, receiving its telemetry data and sending commands. This initial phase was a delicate balance of automation and human intervention, a seamless collaboration between machine and mind, orchestrated from a distant blue marble. The scientific community eagerly awaited the first images and data, knowing that this mission held the potential to revolutionize our understanding of the outer solar system. The very act of sending such a complex machine across such vast distances was a testament to human ambition and our capacity for long-term planning and execution. It was a journey born of curiosity, fueled by innovation, and guided by the principles of celestial mechanics. The initial deployment and trajectory correction maneuvers were critical, ensuring that Voyager was perfectly positioned to begin its grand tour, a silent sentinel embarking on a voyage of cosmic discovery. The precision of the launch and the subsequent maneuvers were paramount, setting the stage for the incredible discoveries that would follow, a testament to the ingenuity that launched this emissary into the void. This initial departure, a whisper of intent from our pale blue dot, was the genesis of a cosmic journey, setting the stage for the silent symphony of discovery that would unfold across the immensity of space. The silent launch, humanity's first tentative step beyond. On a bright, crisp morning in September of 1977, a colossal thunderclap echoed across the Florida coast. It was not the sound of nature, but the triumphant roar of human ambition, a Vulcan Centaur rocket lifting off from Cape Canaveral, carrying with it not just scientific instruments, but a profound hope. This was the genesis of Voyager 1, a vessel destined to become humanity's furthest emissary, a silent, unblinking eye peering into the profound darkness beyond our solar system. The launch itself was a marvel of engineering, a ballet of controlled power designed to escape Earth's gravitational pull with precision and grace. Every component, every calculation, every ounce of fuel was meticulously planned to give this intrepid probe the initial velocity it needed to embark on its epic, decades-long odyssey. This was not a haphazard departure. It was a deliberate, calculated, and deeply intentional push from our familiar cosmic neighborhood into the vast, unknown expanse. The sheer audacity of sending a physical object, a tangible piece of our world, on a journey that would stretch for billions of miles, and eventually into the interstellar medium, is a testament to the human spirit's insatiable curiosity. It was a moment when our collective gaze turned outward, not just to observe, but to explore, to touch, to venture where no human-made object had ever dared to go before. The Earth, our blue marble, began to recede, its familiar continents and oceans shrinking to a distant memory, as Voyager 1, propelled by the raw power of rockets, began its slow, steady ascent into the void. The launch was more than just a physical event. It was a symbolic act, a declaration that humanity, despite its terrestrial confines, possessed the drive and the ingenuity to reach for the stars, or at least, to begin the long, silent conversation with them. The initial trajectory was critical, a delicate dance with gravity and inertia, setting the stage for the incredible gravitational slingshot maneuvers that would later propel Voyager 1 to speeds unimaginable for any terrestrial vehicle. This was not just a journey of discovery. It was a journey of self-discovery, as we projected our own aspirations and our own understanding of the universe outward, carried by a silent sentinel. The vibrations of the launch, the immense forces at play, were all part of a carefully orchestrated symphony, a prelude to the quiet, persistent hum of its instruments as it began its lonely vigil. It was the first tentative step, a small push from our cradle, into the immensity of the cosmos, a whisper of our existence carried on the solar wind, destined to travel for eons. The sheer volume of energy required to achieve escape velocity, to break free from Earth's gravitational embrace, is staggering. Millions of pounds of thrust were generated, a controlled explosion designed to propel Voyager 1 not just into orbit, but onto an escape trajectory, a path that would lead it inexorably away from the sun and towards the stars. The rocket itself was a complex machine, a layered system of engines and fuel tanks, each playing a vital role in the initial push. The upper stage, the Centaur, was particularly crucial, providing the final, powerful boost that would send Voyager 1 on its way to the outer planets. The launch was a culmination of years of research, development, and testing, a testament to the collaborative efforts of thousands of scientists, engineers, and technicians. It was a moment when the abstract concepts of physics and engineering were translated into a tangible reality, a metal spacecraft hurtling through the vacuum of space. The launch window was precise, dictated by the orbital positions of Earth and the outer planets, a cosmic alignment that would allow Voyager 1 to take advantage of gravitational assists, effectively using the gravity of the planets themselves to accelerate its journey. Without these carefully calculated maneuvers, Voyager 1 would never have achieved the speeds necessary to reach the outer solar system and beyond. The launch was the ignition of a grand experiment, a bold venture into the unknown, a physical manifestation of humanity's enduring quest to understand its place in the universe. It was the moment when our technological prowess met the vast, silent canvas of space, initiating a dialogue that continues to this day. The initial trajectory was not a straight line, but a carefully plotted arc, designed to encounter Jupiter and Saturn at specific times, allowing their immense gravitational fields to do the heavy lifting of acceleration. This ingenious use of planetary gravity, a concept known as a gravitational assist or slingshot, was a cornerstone of the Voyager mission's success, enabling the spacecraft to achieve speeds that would have been impossible with its onboard propulsion alone. The launch was the culmination of immense effort, a moment when the dreams of countless individuals took physical form and began their solitary journey. It was the beginning of a story written not in words, but in data streams and faint radio signals, a narrative of exploration that would unfold over decades. The feeling of liftoff, the immense power surging through the rocket, was a tangible representation of humanity's desire to transcend its terrestrial limitations. The carefully chosen launch date and time were not arbitrary, but were dictated by the intricate orbital mechanics of the solar system, ensuring that Voyager 1 would arrive at its planetary targets at the optimal moments to utilize their gravitational influence. This complex choreography of celestial mechanics underscores the profound understanding of the universe that underpinned the Voyager mission. The rocket's ascent was a fiery spectacle, a brief, brilliant display of human power against the backdrop of an indifferent sky, a prelude to the silent, enduring journey that awaited the spacecraft. The separation of rocket stages was a series of precisely timed events, each shedding weight and allowing the remaining engines to propel Voyager 1 ever faster, ever further from its home world. This incremental acceleration was key to achieving the necessary velocity for its ambitious trajectory. The initial trajectory was set to carry Voyager 1 on a path that would eventually take it out of the solar system, a feat that required an initial velocity far greater than that needed for orbital insertion. It was a launch designed for escape, for a departure that would be permanent. The images of the launch, the towering rocket against the blue sky, are etched in the collective memory of humanity, a symbol of our unyielding drive to explore the unknown. It was the moment when a physical object, imbued with our curiosity, began its long, silent voyage. The sheer force unleashed during the launch was a testament to the advanced engineering and scientific knowledge that made such a mission possible. It was a controlled explosion, harnessed for the purpose of discovery. The subsequent trajectory was a complex mathematical equation, a path calculated to intersect with the gravitational wells of Jupiter and Saturn, transforming their pull into powerful accelerations. This reliance on planetary assistance was a stroke of genius, allowing Voyager 1 to achieve speeds that would have been unattainable otherwise. The launch was the spark that ignited a journey of unprecedented scale, a journey that would redefine our understanding of the solar system and our place within it. The initial stages of the launch were dedicated to overcoming Earth's substantial gravity, a force that seeks to hold all objects close to its surface. The immense thrust generated by the rocket engines was necessary to break free from this powerful embrace. The carefully selected launch azimuth, the direction of the rocket's ascent, was optimized to align Voyager 1 with its planned trajectory towards the outer planets, a crucial step in setting the stage for its gravitational assists. The launch itself was a testament to the precision and dedication of the teams involved, a brief, intense period of activity that set in motion a mission that would last for generations. It was the moment when a fragile human creation began its solitary, majestic journey through the cosmos, carrying with it the hopes and dreams of a species looking outward. The initial acceleration was the most critical phase, as it determined whether Voyager 1 would achieve escape velocity and embark on its intended path, or remain bound to Earth's gravitational influence. The successful separation of the launch vehicle stages was a critical sequence of events, ensuring that the spacecraft was progressively shed of its unnecessary weight, allowing for ever-increasing speeds. This methodical shedding of mass is a fundamental principle in rocketry, maximizing efficiency and enabling greater velocity. The launch was the physical embodiment of a grand scientific inquiry, a question posed to the universe, carried on the wings of fire and steel. It was the genesis of a dialogue that would stretch across the void, a testament to our innate desire to understand the vastness that surrounds us. The initial trajectory was not merely about escaping Earth, but about setting up a series of precise encounters with the outer planets, each a carefully orchestrated gravitational push. This intricate dance with celestial bodies is what allowed Voyager 1 to reach such astonishing speeds and distances. The launch was the ignition of a profound cosmic conversation, a physical manifestation of humanity's yearning to reach beyond its terrestrial home. It was the first step in a journey that would redefine our understanding of the solar system and our place within the grand tapestry of the universe. The initial velocity imparted by the launch was the critical factor, determining the ultimate fate of the spacecraft and its ability to explore the outer reaches of our solar system and beyond. The subsequent maneuvers were designed to build upon this initial momentum, transforming a terrestrial departure into an interstellar voyage. The launch was a fleeting moment of intense energy, a fiery prelude to an era of silent, persistent exploration, a testament to our species' enduring drive to seek out the unknown. It was the spark that ignited a journey of discovery, a whisper of human presence venturing into the profound quiet of the cosmos. The silent launch was humanity's first, tentative step beyond our terrestrial cradle, a whisper of ambition carried on a pillar of fire, setting a course for the grandest of explorations. A celestial dance, the gravitational assist maneuvers. Imagine, if you will, a spacecraft, a marvel of human ingenuity, not merely propelled by its own engines, but by the very fabric of spacetime itself, by the colossal, silent presence of planets. This is the essence of a gravitational assist, a maneuver so elegant, so profound. It allows a spacecraft to achieve speeds and trajectories that would otherwise be impossible, a cosmic ballet orchestrated by celestial bodies. Voyager 1, in its audacious quest to leave our solar system, relied heavily on these celestial dances, using the immense gravitational pull of the gas giants to slingshot itself further and further into the darkness. It wasn't about brute force, but about a sophisticated understanding of physics, about harnessing the momentum of worlds. Think of it like a skilled surfer catching a wave, but instead of water, it's the gravitational field of a planet, and instead of a surfboard, it's a spacecraft. The planet, in its orbit around the sun, possesses a tremendous amount of kinetic energy. When a spacecraft approaches it and is carefully directed, a portion of that planetary motion can be transferred to the spacecraft. It's not a simple push, but a complex interaction. The spacecraft enters the planet's gravitational influence. It begins to fall towards the planet, accelerating. Then, as it swings around the planet, it moves into a region where the planet's orbital velocity is working in concert with the spacecraft's trajectory. The spacecraft essentially steals a tiny fraction of the planet's orbital energy, but in doing so, it gains a significant boost in speed. This boost is not just about going faster. It's about changing direction, about setting a course for the next leg of an epic journey. Without these maneuvers, Voyager 1 would have taken an immeasurably longer time to reach the outer reaches of our solar system, and perhaps would never have had the velocity to escape it entirely. The engineers who designed these trajectories were not just building a machine, they were choreographing a cosmic performance, a testament to humanity's ability to understand and manipulate the fundamental forces of the universe. It's a process that requires immense precision. The angle of approach, the speed of the spacecraft, the mass of the planet, all these factors must be calculated with extraordinary accuracy. A slight miscalculation could send the spacecraft off course, wasting precious fuel or even jeopardizing the mission. But when it works, it's a thing of breathtaking beauty. Voyager 1, in its early years, performed several such maneuvers, each one a critical step in its long voyage. Its encounter with Jupiter, for instance, was not just an opportunity to study the giant planet and its moons. It was a pivotal moment that propelled Voyager onto its path towards Saturn, and ultimately beyond. The energy gained from Jupiter was substantial, setting the stage for the subsequent encounter with Saturn. And then, the dance continued. Saturn, with its majestic rings, offered another opportunity for a gravitational assist, further accelerating Voyager and refining its trajectory. It's a cascade of celestial interactions, each one building upon the last, a testament to the interconnectedness of the solar system. This isn't just about reaching a destination. It's about the journey itself, about the profound beauty of physics in action. The gravitational assist is a masterclass in cosmic efficiency, a way to achieve the extraordinary with seemingly minimal effort, by working with, rather than against, the natural forces at play. It demonstrates a deep understanding of the universe's mechanics, a willingness to learn from the grand cosmic machinery that surrounds us. The spacecraft becomes a participant in the solar system's ongoing ballet, its path dictated by the gravitational whispers of giants. It's a remarkable feat of engineering and physics, allowing us to touch the distant stars by leveraging the very forces that hold the cosmos together. The meticulous planning behind these maneuvers underscores the patience and dedication of the scientists and engineers who sent Voyager on its way, transforming a simple probe into a cosmic dancer. This intricate interplay of forces allows us to explore further, to dream bigger, and to understand our place within this vast, dynamic universe. The energy transfer is subtle yet monumental, a secret handshake between a human creation and the ancient power of planets. It's a quiet testament to our ability to observe, to calculate, and to participate in the grand cosmic waltz. The precision required is astounding, a testament to human intellect applied to the grandest of canvases. Each successful maneuver is a triumph, a step further into the unknown, guided by the invisible hands of gravity. This elegant physics is what allows us to push the boundaries of our exploration, to extend our reach far beyond what our own engines could ever achieve alone. It is a profound lesson in working with the universe, rather than against it, a demonstration of how understanding fundamental forces can lead to extraordinary outcomes. The spacecraft becomes an extension of the planet's own motion, a partner in its celestial promenade. This is not just science, it is art, painted across the vast canvas of space with the brushstrokes of gravity. It's a reminder that sometimes, the most powerful journeys are not achieved by sheer force, but by a deep understanding and skillful application of natural principles. The gravitational assist is a quiet, yet incredibly powerful, tool in our cosmic exploration, a whisper of physics that propels us towards the stars. It is a reminder that the universe is a place of intricate connections, where even the smallest object can be influenced by the grandest of celestial bodies, and where human ingenuity can harness these forces to achieve the seemingly impossible. Through the silent choreography of gravity, a spacecraft learns to dance with giants, borrowing their momentum to pirouette across the vastness of space. Jupiter's embrace, a world of storms and moons. Our journey, guided by the enduring spirit of exploration, now brings us to the colossal presence of Jupiter, a planet so immense it dwarfs all others in our solar system. This gas giant, a swirling vortex of unimaginable scale, exerted a gravitational pull so profound that it became a pivotal point in Voyager 1's trajectory, a celestial dance orchestrated by the very fabric of space-time. To understand Jupiter's embrace is to comprehend the immense forces that shaped our early solar system and continue to influence the cosmic ballet around us. Voyager 1, in its audacious leap outward, was drawn into this gravitational well, a momentary yet crucial detour that would slingshot it further into the unknown. The sheer mass of Jupiter, more than twice that of all the other planets combined, creates a gravitational field that warps the space and time around it, a phenomenon predicted by Einstein and now tangibly experienced by our intrepid probe. This wasn't a simple encounter. It was an intricate maneuver, a carefully calculated gravitational assist, where Voyager 1 used Jupiter's own momentum to accelerate its journey towards the outer reaches of our solar system and beyond. Imagine a celestial ballet, where planets and spacecraft alike adhere to an unseen choreography, their paths dictated by the invisible threads of gravity. Jupiter, in its majestic power, offered Voyager 1 not just a change in direction, but a significant boost in speed, a vital acceleration that would shave years off its journey to the stars. This gravitational embrace is a testament to the elegant simplicity of physics, where immense cosmic bodies can be harnessed for propulsion, allowing humanity to reach further than ever before. The data collected during this passage offered unprecedented insights into the dynamics of gas giants, the complex atmospheric systems, and the myriad of moons that orbit this king of planets. We witnessed the raw power of Jupiter's magnetic field, a colossal magnetosphere that stretches millions of kilometers into space, trapping charged particles in a dazzling, yet dangerous, embrace. This magnetic field is so powerful that it can create auroras, celestial light shows, on a scale far grander than those seen on Earth, a constant reminder of the immense energy contained within this giant world. The swirling atmosphere of Jupiter is a spectacle in itself, a canvas of vibrant colors and colossal storms, the most famous of which is the Great Red Spot, a hurricane-like storm that has raged for centuries, larger than our entire planet. Voyager 1 provided us with close-up views of this enduring tempest, revealing its intricate patterns and the turbulent winds that drive it. Beyond the storms, Jupiter is orbited by a diverse collection of moons, each with its own unique character and geological history. From the volcanic fury of Io, constantly reshaped by its internal heat, to the icy plains of Europa, a world suspected to harbor a subsurface ocean, these moons represent a fascinating microcosm of planetary evolution. Voyager 1's close flybys of these moons provided crucial data, hinting at the potential for life beyond Earth and expanding our understanding of the diverse environments that can exist within a single planetary system. The intricate interplay of Jupiter's gravity and its moons' orbits creates a complex system, a miniature solar system within our own, where tidal forces sculpt landscapes and generate internal heat. The discovery and detailed observation of these moons were among the most significant achievements of the Voyager missions, revealing a hidden world of geological activity and astonishing diversity. The data streamed back from Voyager 1 painted a picture of a dynamic, ever-changing world, a place of immense power and delicate balance. It was a moment when humanity, through its robotic emissary, peered into the heart of a gas giant, gaining a profound appreciation for the sheer scale and complexity of our solar system. The lessons learned from Jupiter's embrace extend beyond mere astronomical observation. They speak to the interconnectedness of celestial bodies and the elegant laws that govern their movements. This encounter with Jupiter was not just a scientific mission. It was an act of cosmic contemplation, a chance to witness the raw, untamed beauty of a planetary giant and the diverse family of worlds that call it home. The gravitational assist was a crucial step, a necessary hurdle overcome, allowing Voyager 1 to continue its inexorable march towards the stars, carrying with it the awe-inspiring secrets of the Jovian system. The sheer scale of Jupiter, its powerful magnetic field, its tempestuous atmosphere, and its diverse moons all contribute to a breathtaking spectacle, a testament to the immense forces at play in our universe. This encounter served as a profound reminder of our place within this grand cosmic tapestry, a tiny observer marveling at the majestic workings of the solar system. The data gathered, the images captured, and the understanding gained during this phase of Voyager's journey have irrevocably altered our perception of the gas giants and the potential for complex systems within our own celestial neighborhood. The Jovian system, a realm of both immense power and subtle beauty, offered a glimpse into the extraordinary diversity that exists among the planets, a diversity that continues to inspire wonder and fuel our relentless quest for knowledge. The gravitational hug of Jupiter was a pivotal moment, a testament to the power of physics and the ingenuity of human exploration, propelling our emissary further into the silent, starry expanse. Jupiter's immense gravity, a gentle yet irresistible hand, guided our probe onward, a cosmic choreographer setting the pace for the journey beyond. Saturn's rings are not solid structures, but rather vast collections of icy particles, ranging in size from dust grains to mountains, all orbiting the planet in a delicate, dynamic equilibrium. These rings, so breathtakingly visible from Earth, are a testament to the chaotic yet ordered processes that shape celestial bodies. They are a cosmic ballet, a grand performance of gravitational forces and material interactions that has unfolded over eons. When we gaze upon Saturn's rings, we are witnessing a breathtaking display of physics in motion, a stark and beautiful illustration of how even the most seemingly solid and enduring features in the cosmos are, in reality, ephemeral arrangements of fundamental particles, constantly in flux. The sheer scale of this icy collection is almost incomprehensible, stretching tens of thousands of kilometers across. Yet in many places, they are astonishingly thin, sometimes no more than a few tens of meters thick. This delicate flatness against the immense width is a profound paradox, a visual representation of how seemingly impossible configurations can arise from simple, fundamental laws. The composition of these rings is overwhelmingly water ice, with only a small percentage of rocky material, a purity that contributes to their dazzling reflectivity. This pristine icy nature means that sunlight, when it strikes these particles, bounces back with remarkable intensity, giving the rings their characteristic ethereal glow. The individual particles within the rings are not static. They are in constant motion, colliding, grinding against each other, and subtly altering their orbits. These collisions, far from being destructive, are part of the ongoing sculpting process, smoothing out the edges and maintaining the overall structure. The gravitational influence of Saturn's moons plays a crucial role in this intricate dance. These moons act as shepherds, their gravitational tugs carving out gaps and maintaining the sharp edges of the ring system. The Cassini division, for example, a prominent gap within the rings, is largely due to the gravitational resonance with the moon Mimas. Other moons, like Pan and Daphnis, actually orbit within the rings themselves, their gravitational pull creating ripples and waves that are visible as intricate patterns. These small moons, often no more than a few kilometers across, exert a disproportionately large influence on the grand structure of the rings, a powerful reminder that even the smallest forces can have significant, far-reaching consequences in the universe. The sheer variety of ring features is astounding, from the broad, bright A and B rings to the fainter C and D rings, each with its own unique characteristics and complexities. There are also transient features, like propeller-like structures created by embedded moonlets, and wavy patterns that hint at the ongoing gravitational interactions. Voyager 1, in its distant journey, has provided us with an unparalleled perspective on this magnificent spectacle, revealing details that were previously hidden from our view. The images and data transmitted back by Voyager have allowed us to understand the dynamic nature of these rings, to appreciate their intricate composition, and to marvel at the complex interplay of forces that hold them together. The rings are not a static backdrop. They are a living, breathing entity, a testament to the continuous creation and evolution that defines the cosmos. The particles within the rings are constantly being replenished by impacts from micrometeoroids and possibly by the fragmentation of small icy moons. This ongoing process of creation and destruction, of assembly and disaggregation, is a fundamental characteristic of the universe, a constant reminder that nothing is truly fixed, and that change is the only constant. The sheer volume of material in Saturn's rings is enormous, estimated to be enough to form a small moon, yet it is spread out over such a vast area, creating an illusion of solidity that belies its true nature. This distribution of matter is a key factor in the ring's stability, preventing them from collapsing into a solid disk. The delicate balance between the gravitational pull of Saturn and the orbital motion of the ring particles is what maintains their existence, a precarious equilibrium that has persisted for billions of years. The subtle variations in density and brightness across the rings are not random. They are the result of complex wave phenomena, density waves, and bending waves that propagate through the ring material, orchestrated by the gravitational influence of Saturn's larger moons. These waves are like ripples on a pond, spreading out from points of gravitational disturbance, and they create the intricate banding and patterns we observe. The sheer artistry of nature is on full display in Saturn's rings, a masterpiece of celestial engineering that continues to inspire awe and wonder. The fact that these rings are composed primarily of ice, a substance so familiar to us on Earth, yet arranged in such an alien and majestic way, adds another layer of fascination. It speaks to the universality of physical laws, that even in the most extreme environments, the same fundamental principles of gravity and motion are at play. Voyager's passage through this region was a pivotal moment in our understanding of planetary systems, offering a close-up view of a phenomenon that had captivated humanity for centuries. The detailed observations of the ring particles, their sizes, shapes, and orbital characteristics, have provided invaluable data for refining our models of planetary formation and evolution. We are beginning to understand that the processes that formed Saturn's rings might be common throughout the galaxy, suggesting that ring systems could be a ubiquitous feature of planetary systems beyond our own. This thought, that countless other worlds might be adorned with their own celestial jewelry, is a profoundly humbling and awe-inspiring realization. The rings are a constant reminder of the dynamic processes that shape the universe, a reminder that even in the vast emptiness of space, there is an intricate and beautiful order to be found. The particles themselves, though small and individually insignificant, collectively create a spectacle of unparalleled grandeur, a testament to the power of unity and the beauty of emergent complexity. The Voyager mission, by venturing so close, allowed us to witness this cosmic ballet not as a distant, hazy image, but as a tangible, intricate system, revealing the secrets of its formation and its ongoing evolution. The intricate structure, the dynamic interactions, and the sheer scale of Saturn's rings are a profound reminder of the universe's capacity for both immense power and delicate artistry, a silent symphony of ice and rock playing out across the cosmos. And in their silent, shimmering presence, they offer a profound perspective on the enduring beauty that can arise from the most fundamental of cosmic ingredients. The edge of the heliosphere, entering uncharted territory. We stand at a precipice, a boundary so profound it redefines our understanding of home. For years, Voyager 1 has been traversing the vast expanse, propelled by the relentless push of solar wind, a constant outward stream of charged particles emanating from our sun. This solar wind creates a protective bubble, a cosmic shield known as the heliosphere, which encompasses all the planets, moons, asteroids, and comets of our solar system. It is within this heliosphere that our familiar cosmic neighborhood exists, a region where the sun's influence is paramount. However, this bubble is not infinite. It has a limit, a frontier where the solar wind's outward pressure is finally met and overcome by the relentless interstellar medium. the diffuse, magnetized plasma that permeates the space between stars. This boundary, known as the heliopause, marks the true edge of our Sun's dominion, the point beyond which the solar wind can no longer hold sway. Voyager 1, in its extraordinary journey, has been steadily approaching this monumental demarcation. Imagine it as a vast, invisible ocean current, where the Sun's outflow is like a gentle but persistent river, and the interstellar medium is the vast, deep, and powerful ocean beyond. As Voyager 1 travels further, it begins to feel the subtle, yet significant changes in this environment. The density of charged particles shifts, the magnetic field lines begin to orient themselves differently, and the very nature of the cosmic environment begins to transform. This is not a sudden, dramatic event, but rather a gradual transition, a slow immersion into an entirely new realm. It's a testament to the sheer scale of the cosmos that such a transition can take decades to traverse. The heliosphere, while vast from our terrestrial perspective, is but a small island in the immense cosmic ocean. The heliopause represents the point where the solar wind, which has been our constant companion, begins to weaken, and the whispers from the galaxy at large become more pronounced. It is a region of immense scientific interest, a place where the Sun's influence meets the fabric of interstellar space. Here, the particles are older, originating from distant stellar explosions and the very formation of our galaxy. The magnetic fields are not those generated by our Sun, but are woven into the larger tapestry of galactic forces. Voyager 1, in crossing this threshold, is no longer merely a probe of our solar system. It becomes an emissary, a direct observer of the interstellar realm, carrying with it the unique perspective of having originated from within a star system. This transition is a significant milestone, a moment when humanity's tangible presence extends beyond the Sun's immediate grasp into the true, untamed wilderness of interstellar space. The data it collects here is invaluable, offering us our first direct sensory experience of the vastness that lies between the stars, a region previously only imagined through indirect observations and theoretical models. It is a journey into the unknown, a step into a cosmic wilderness, where the familiar rules of our solar system begin to bend and transform. The heliosphere is our solar system's protective bubble, but the heliopause is where that bubble meets the immense, unyielding pressure of the galaxy. Voyager 1 is not just traveling through space. It is traveling through changing environments, each one a testament to the dynamic and interconnected nature of the cosmos. This boundary is not a wall, but a permeable membrane, a region where the solar wind and the interstellar medium mingle and interact, creating a unique and complex plasma environment. It is here that the Sun's outward expulsion of plasma begins to be compressed and deflected by the interstellar magnetic field. The particles within the heliosphere are predominantly solar in origin, carrying the chemical and energetic signatures of our Sun. As Voyager 1 approaches and then crosses the heliopause, it begins to encounter particles that have never been within the heliosphere, particles born from stars in distant galaxies, from supernovae that occurred eons ago, and from the very processes that shaped our Milky Way. This transition is marked by a dramatic increase in the density of these interstellar particles and a significant change in the direction and strength of the magnetic fields. The energetic particles that bombard Voyager 1 in this region are not the same as those encountered within the heliosphere. They carry different isotopic ratios, different energy spectra, and provide clues about the origin and evolution of cosmic rays. The heliopause is not a perfectly defined line. It is a region of interaction, a zone where the solar wind is slowed down, heated, and compressed before it can escape into the interstellar medium. This region is known as the heliosheath, and it is a crucial transitional zone that Voyager 1 traversed before reaching the true interstellar space. The pressure from the interstellar medium here is significant, pushing back against the outward flow of the solar wind. This compression can lead to the formation of shock waves and complex plasma structures. The magnetic field within the heliosheath is also significantly altered, becoming more ordered and aligned with the interstellar magnetic field. Voyager 1's instruments are meticulously measuring these changes, providing an unprecedented look at the physics of this boundary region. The data from this phase of the mission is crucial for understanding how stellar winds interact with the interstellar medium, a fundamental process that occurs around virtually all stars in the galaxy. It helps us to comprehend the formation and evolution of planetary systems and the potential for life to exist beyond our own solar system. The heliosphere is our solar system's unique signature in the galaxy, and the heliopause is the point where that signature begins to blend with the cosmic background. It is a place of profound scientific discovery, a testament to our innate human drive to explore and understand our place in the universe. The edge of the heliosphere is not an end, but a beginning, a gateway to a vaster, more ancient cosmic landscape. As the sun's gentle breath begins to fade, and the interstellar winds whisper their ancient tales, we find ourselves at the very edge of our solar embrace, a quiet frontier where the known gives way to the truly magnificent unknown. And in this transition, we glimpse the grander tapestry of existence, a soothing reminder of our small, yet significant, place within the infinite. The interstellar medium, the true void, begins. We are about to venture beyond the familiar, beyond the last vestiges of our sun's direct influence. Imagine, if you will, a boundary, not a sharp line etched in cosmic stone, but a gradual thinning, a lessening of familiar forces. This is the heliopause, the invisible threshold that Voyager 1 crossed, marking its true entry into the interstellar medium. For decades, Voyager had been traversing the heliosphere, the vast, bubble-like region dominated by the solar wind and the sun's magnetic field. This was, in essence, our solar system's magnetic and energetic signature projected out into the galaxy. But the interstellar medium is something profoundly different. It is the space between the stars, the vast, diffuse ocean in which our sun, and indeed our entire solar system, is but a tiny, solitary island. This medium is not empty, not in the way we might intuitively think of a vacuum. It is, rather, an incredibly rarefied soup of charged particles, ions and electrons, and magnetic fields that originate from countless stars and cosmic events throughout our galaxy. The density of this interstellar plasma is astonishingly low, far lower than any vacuum we can artificially create on Earth. We're talking about mere atoms per cubic centimeter, a stark contrast to the trillions upon trillions of particles we find in even the most perfect terrestrial vacuum. These particles are primarily hydrogen and helium, the most abundant elements in the universe, remnants of the Big Bang itself. But they are not static. They are in constant motion, buffeted by stellar winds from neighboring stars, swept along by galactic magnetic fields, and energized by distant supernovae. These cosmic winds, unlike the solar wind we are accustomed to, are not emanating from a single, central source. Instead, they are a complex interplay of forces, creating a dynamic and ever-changing environment. Voyager 1's instruments, designed to detect these subtle shifts, began to register a dramatic increase in the density of these charged particles as it pushed further out. The pressure exerted by the solar wind, which had been the dominant force for so long, began to wane, allowing the interstellar plasma to press in. This transition wasn't instantaneous. It was a gradual phase-out of one dominant influence and a slow fade-in of another. The magnetic field lines, too, shifted their orientation. Within the heliosphere, the Sun's magnetic field lines are largely organized, extending outwards in a somewhat predictable fashion. In the interstellar medium, however, these lines become more turbulent, more chaotic, influenced by the grander magnetic fields of the Milky Way itself. These fields act like invisible currents, guiding the flow of charged particles and shaping the very structure of this cosmic ocean. Voyager 1, by simply existing and transmitting data, became our first direct probe into this alien realm. It was like sending a single, tiny sensor into a vast, silent ocean, tasked with reporting on the currents, the temperature, and the very composition of the water. The data it sent back revealed a universe far more active and complex than we had previously imagined, a realm governed by forces on scales that dwarf our everyday comprehension. The density of the plasma increased, the magnetic field felt different, and the overall environment was unmistakably alien. This was not the quiet emptiness we might have envisioned, but a subtle, pervasive presence, a cosmic hum of activity. It is here, in this vast expanse, that the true nature of the cosmic void begins to unfold, a space teeming with the whispers of distant stars and the echoes of galactic evolution. And in this vast, quiet ocean between the stars, we found a new understanding of our place, a tiny mote adrift in a sea of cosmic possibility. Cosmic rays, the unseen messengers of the galaxy. The universe, in its quiet grandeur, is not entirely silent. Beyond the gentle hum of starlight and the whisper of solar winds, there exists a constant, energetic bombardment, an unseen tide of particles that originate from the most violent and distant corners of the cosmos. These are the cosmic rays, and they are, in essence, the universe's most ancient and persistent messengers. Imagine them as phantom bullets, hurled across unimaginable distances, carrying with them tales of supernovae explosions, active galactic nuclei, and perhaps even the birth pangs of stars. They are not light, nor are they sound, but they are a fundamental component of the interstellar medium, a pervasive presence that shapes the very fabric of space and influences the evolution of celestial bodies. Voyager 1, as it ventures further from the Sun, finds itself increasingly immersed in this cosmic deluge. These are not your everyday particles. They are atomic nuclei stripped of their electrons, traveling at speeds so close to the speed of light that their origins are often incredibly difficult to pinpoint. Some of these particles are as simple as protons, the nuclei of hydrogen atoms, while others are heavier, comprising helium nuclei, or even the nuclei of elements far up the periodic table, such as iron and nickel. Their energies are staggering, far exceeding anything that can be generated in terrestrial particle accelerators, making them a unique window into the most energetic phenomena in the universe. The sheer kinetic energy contained within a single, high-energy cosmic ray is comparable to that of a well-thrown baseball, yet these particles are infinitesimally small, existing at the subatomic level. This immense energy is not an accident. It is a consequence of the cataclysmic events that forge them. Supernova remnants, the expanding shells of gas and dust left behind after a massive star explodes, are thought to be primary cosmic ray factories. The shock waves generated by these explosions can accelerate charged particles to incredible velocities through complex magnetic interactions. Another significant source is believed to be the supermassive black holes that reside at the centers of galaxies, particularly those that are actively feeding on surrounding matter, creating powerful jets of plasma that can propel particles to relativistic speeds. Understanding cosmic rays is crucial for comprehending the universe's energetic budget and its chemical evolution. When these high-energy particles collide with the interstellar medium, they can trigger chemical reactions, creating new molecules and influencing the composition of gas clouds where stars and planets are born. They can also interact with planetary atmospheres, contributing to atmospheric chemistry and even influencing the evolution of life, though the direct impact on Earth is largely shielded by our planet's magnetic field and atmosphere. For Voyager 1, however, this shielding is absent. The spacecraft is directly exposed to this relentless stream, and the data it collects provides invaluable insights into the nature and intensity of cosmic rays in the interstellar medium. The instruments aboard Voyager are designed to detect and measure these particles, charting their energy spectra, their composition, and their direction of travel. This information allows scientists to infer the processes that accelerate them and the environments from which they originate. The challenge lies in distinguishing between cosmic rays originating from within our solar system and those that have traversed the vast interstellar gulf. As Voyager 1 moves further out, the influence of the Sun's magnetic field, which deflects many of these energetic particles, diminishes, allowing a clearer picture of the true interstellar cosmic ray population to emerge. The study of cosmic rays is a detective story, piecing together clues from these energetic fragments to understand the most powerful events in the cosmos. They are the invisible ink of the universe, writing its history in trails of energy and matter. The universe speaks in a language of energetic particles, a constant, invisible whisper that carries the echoes of cosmic violence and creation, reminding us of the dynamic forces that shape existence. And in their silent passage, they connect us to the grandest spectacles of the cosmos, a profound and humbling truth. The plasma torus, a symphony of charged particles. As Voyager 1 continues its silent, inexorable journey, it ventures through regions of space where the sun's influence, though diminishing, still sculpts the very fabric of its surroundings. One such remarkable phenomenon, particularly associated with the giant planets, is the plasma torus. Imagine a vast, invisible donut, a swirling ring of electrically charged particles, ions and electrons, that encircles a planet, held in place by its immense gravitational pull and the subtle yet powerful dance of magnetic fields. This is a plasma torus, and it is a testament to the dynamic, energetic nature of our solar system, even in its outer reaches. For Voyager 1, encountering the plasma torus of Jupiter was an early encounter with this energetic ballet. Jupiter's magnetosphere, a colossal bubble of magnetic force extending millions of kilometers into space, traps particles ejected from its innermost moon, Io, a world of intense volcanic activity, constantly spews sulfur dioxide gas into space. This gas is then ionized, meaning its atoms lose or gain electrons, transforming it into a plasma, a state of matter unlike the solids, liquids, or gases we are familiar with on Earth. These newly formed ions, predominantly sulfur and oxygen, are then captured by Jupiter's powerful magnetic field. The field lines, acting like invisible conduits, guide these charged particles into a donut-shaped region around Jupiter's equator, forming the Jovian plasma torus. This torus is not a static entity. It is a vibrant, dynamic system. Particles within the torus are energized, some reaching incredibly high speeds, creating a constant flow and exchange of energy. The temperature within this plasma can be astonishingly high, reaching millions of degrees Celsius. Although due to its extremely low density, it doesn't feel hot in the way we understand heat. Voyager's instruments were able to measure the density, temperature, and composition of this plasma, providing invaluable data about the complex interactions between a planet's magnetosphere and its moons. The plasma torus is a crucial component in understanding the magnetospheric environment of gas giants. It plays a significant role in planetary aurorae, the spectacular light shows seen in the skies of planets like Jupiter and Saturn. The energized particles from the torus can be channeled along magnetic field lines towards the planet's poles, where they collide with atmospheric gases, exciting them and causing them to emit light. Furthermore, the plasma torus is a source of energetic particles that can pose a radiation hazard to spacecraft and potentially influence the atmospheres of moons within or near the torus. For Voyager 1, this encounter was a crucial step in understanding the diverse and energetic environments that exist beyond Earth. It revealed a universe far more active and complex than a simple vacuum, a place where magnetic fields can shape vast, invisible structures teeming with charged particles, a cosmic symphony played out in the silent expanse. The plasma torus, a swirling ring of energetic particles, whispers tales of planetary power and celestial interaction, reminding us that even in the deepest quiet, vast, invisible forces are perpetually at play. Voyager's compass, navigating the galactic magnetic field. The magnetic field of a celestial body acts as an invisible shield, a fundamental force shaping the very nature of space around it. For Voyager 1, as it ventures ever deeper into the interstellar medium, understanding and navigating this pervasive, yet often subtle, galactic magnetic field is akin to possessing an ethereal compass. It is not a needle pointing north, but rather a complex interplay of forces that dictates its path, influences its environment, and provides invaluable data about the vast, unseen architecture of our galaxy. The Sun, our star, possesses its own magnetic field, the heliosphere, which extends far beyond the orbits of the planets, creating a bubble of solar influence that shields us from some of the harsher aspects of interstellar space. However, as Voyager 1 has now well and truly exited this heliosphere, it has entered a realm where the magnetic fields generated by countless other stars, nebulae, and the very fabric of the Milky Way galaxy itself become the dominant forces. These galactic magnetic fields are not uniform. They are intricate, with lines of force weaving through the interstellar medium like invisible threads. They are generated by the motion of charged particles within the galaxy, a process known as a dynamo effect, similar in principle to how Earth's magnetic field is generated by the motion of molten iron in its core. These fields are incredibly weak compared to the magnetic fields we encounter in our daily lives, often measured in microgauss or nanotesla. Yet over astronomical distances, their cumulative effect is profound. Voyager 1 is equipped with a magnetometer, a sophisticated instrument designed to detect and measure these faint magnetic fields. As it moves, This instrument continuously samples the magnetic environment, recording the strength and direction of the field lines. This data is crucial for understanding the dynamic nature of interstellar space. For instance, the magnetic field plays a significant role in the propagation of cosmic rays, high-energy particles that originate from supernovae and other energetic cosmic events. These rays are affected by magnetic fields, being deflected and channeled along the lines of force. By measuring the intensity and direction of the galactic magnetic field, scientists can better understand the origins and trajectories of these cosmic visitors. Furthermore, the magnetic field influences the distribution of interstellar gas and dust. These fields can compress or expand clouds of gas, playing a role in the formation of new stars and planetary systems. Voyager 1's measurements help paint a picture of these processes occurring on a galactic scale. The heliosphere, while now behind Voyager, had a significant magnetic interaction with the interstellar medium. As the solar wind, a stream of charged particles from the Sun, encounters the interstellar magnetic field, it creates a region of interaction known as the heliosheath. Voyager 1 traversed this region, and its magnetometer data provided unprecedented insights into this boundary. Now, in true interstellar space, the magnetic field is thought to be largely uniform, but still subject to variations and turbulence. These variations can be caused by the passage through different regions of the galaxy, such as near nebulae or stellar clusters. The magnetic field also acts as a conduit for energy transfer within the galaxy. It can store and release energy, influencing phenomena like stellar flares and the behavior of active galactic nuclei. Voyager 1's journey, therefore, is not just a physical traversal of space, but a continuous magnetic survey of our galactic neighborhood. The data it sends back, though faint and requiring immense effort to decipher, is like reading the invisible currents that sculpt the cosmic ocean. It is a testament to human ingenuity that we can equip a probe with instruments capable of detecting such subtle yet fundamental forces, allowing us to perceive the unseen scaffolding of the universe. The magnetic field, though invisible to our eyes, is a tangible force, a silent architect of the cosmos, and Voyager 1, with its diligent measurements, is helping us to understand its grand, pervasive design. The subtle whisper of the galactic magnetic field guides our lonely traveler, revealing the unseen currents that shape the cosmic tapestry. The sun's influence, a fading whisper in the cosmic roar. Our sun, that familiar, life-giving orb that graces our daytime sky, exerts an influence that stretches far beyond the familiar orbits of our planets. This influence, known as the solar wind, is a constant outflow of charged particles, primarily electrons and protons, streaming outwards from the sun's corona at incredible speeds. Imagine it as a vast, invisible bubble, pushing back against the interstellar medium, the tenuous gas and dust that permeates the space between stars. This bubble is called the heliosphere, and Voyager 1, in its extraordinary journey, is now traversing its outer reaches, experiencing the diminishing power of our star. As Voyager 1 ventures further, the solar wind, once a powerful torrent, becomes a mere whisper. The density of these particles decreases significantly, and their energy wanes. The heliosphere, once a robust shield, becomes thinner, more permeable. This transition is not abrupt but gradual, a slow surrender of our sun's dominance as Voyager 1 enters a region where the interstellar medium's own subtle pressures begin to assert themselves. The heliosphere acts like a cosmic windsock, its shape and extent dictated by the balance between the outward flow of the solar wind and the inward pressure of the interstellar medium. As Voyager 1 has moved further from the Sun, this balance has shifted. The solar wind's speed has slowed, and its density has dropped. This means that the heliosphere, while still present, is no longer the dominant force. It is closer to home. It is like standing at the edge of a great hall, where the echoes of a mighty voice are still faintly heard, but the overwhelming presence of the speaker has long since receded. The particles that once rushed past Voyager 1 with immense force, carrying with them the magnetic signature of our Sun, are now more diffuse, their individual presence less pronounced. This change is a fundamental marker of Voyager's progress, a tangible indicator of its increasing distance from its origin. The heliosphere, this vast bubble, is not perfectly spherical. It is compressed on the side facing the direction of the Sun's motion through the galaxy and stretched out on the opposite side, forming a comet-like tail. Voyager 1 is now in a region where the solar wind particles are no longer traveling at their peak speeds, and their magnetic influence is weakening. This is a crucial phase in its journey, a testament to the sheer scale of the solar system and the vastness of the space that lies beyond. The Sun's influence, once so pervasive, becomes a subtle, almost imperceptible force, a fading memory carried on the solar wind's diminishing breath. The journey through the heliosphere is a gradual process of disengagement, a slow uncoupling from the gravitational and energetic embrace of our star. Voyager 1 is experiencing this transition not as a sudden event, but as a continuous, unfolding process. The density of plasma, the ionized gas that constitutes the solar wind, has been observed to decrease significantly as Voyager 1 has moved further out. This decrease in density means that the individual particles are more spread out, and their collective impact is lessened. The magnetic field carried by the solar wind, which originates from the Sun, also weakens with distance. This field plays a crucial role in deflecting cosmic rays, high-energy particles from outside the solar system. As the solar wind weakens, the heliosphere's ability to shield us from these energetic visitors diminishes. Voyager 1's instruments are meticulously recording these changes, providing us with an unprecedented look at the boundary between our solar system and the wider galaxy. The solar wind is a continuous stream of plasma originating from the Sun's upper atmosphere, the corona. It flows outward in all directions, creating a vast magnetic bubble known as the heliosphere. This heliosphere extends far beyond the orbit of Pluto, and it is within this region that Voyager 1 is now operating. As Voyager 1 has traveled further from the Sun, the solar wind has become less dense, and its speed has decreased. This is because the solar wind expands and cools as it travels through space. The heliosphere acts as a protective shield, deflecting many of the high-energy cosmic rays that originate from outside our solar system. However, as Voyager 1 moves further out, this shield becomes weaker. The pressure exerted by the solar wind decreases, and the interstellar medium begins to exert a greater influence. This is a profound shift, as the environment surrounding Voyager 1 changes from one dominated by our Sun to one influenced by the wider galaxy. The solar wind's particles, once energetic and abundant, become more spread out and less potent. The magnetic field carried by the solar wind, which originates from the Sun, also weakens significantly with distance. This weakening magnetic field has implications for the heliosphere's ability to deflect interstellar cosmic rays. The transition from the heliosphere to the interstellar medium is not a sharp boundary, but a gradual transition zone. Voyager 1 is currently in this transition zone, experiencing the diminishing influence of our Sun. The data collected by Voyager 1 provides invaluable insights into the nature of the heliosphere and its interaction with the interstellar medium. It is a testament to human ingenuity and our insatiable curiosity to explore the unknown. The Sun's influence, though fading, has guided Voyager 1 this far, a silent, invisible hand shaping its path through the cosmos. And so, as the Sun's energetic breath grows fainter, we perceive a subtle shift, a grand diminuendo in the cosmic symphony, reminding us that even the most powerful forces eventually yield to the vast, quiet expanse. A fading signal, the challenges of extreme distance. As Voyager 1 continues its silent, inexorable drift away from our solar system, a profound challenge emerges, one that speaks to the very fabric of our connection to this intrepid explorer. The fading signal. The further Voyager travels, the weaker its transmissions become, a consequence of the inverse square law, a fundamental principle in physics that governs the spread of energy, be it light, sound, or radio waves. Imagine a single light bulb. As you move further away, its brightness diminishes not just a little, but significantly. The same applies to the radio waves emitted by Voyager's antenna. These waves, carrying precious data about the interstellar medium, about the magnetic fields and charged particles that populate the void, spread out in all directions, encompassing an ever-expanding sphere. By the time these faint whispers reach Earth, they have traversed billions of kilometers, their energy dispersed across an immense volume of space. This isn't a matter of a faulty transmitter. It's an unavoidable consequence of the vast distances involved. The engineers who designed Voyager knew this would be a hurdle, and they equipped the spacecraft with a powerful radioisotope thermoelectric generator, a nuclear battery that provides a steady, albeit finite, supply of power to its instruments and its crucial communication system. They also employed a highly directional antenna, a dish designed to focus its radio beam as tightly as possible towards our home planet, maximizing the chances of its signal being detected. Yet, even with these ingenious solutions, the signal is undeniably faint. It arrives at Earth as an infinitesimally small wave, easily lost in the background noise of the cosmos, a cacophony of radio emissions from distant stars, galaxies, and even from our own Sun. The Deep Space Network, a global network of giant radio telescopes, acts as our cosmic ear, straining to capture these delicate echoes from the edge of the solar system. These antennas are colossal, capable of focusing on incredibly small areas of the sky, and they employ sophisticated receivers designed to amplify the faintest of signals. But even with these advanced tools, the data stream from Voyager is slow, a trickle of information that requires immense processing power to decipher. Each bit of data represents a triumph over the immense gulf of space, a testament to human ingenuity and persistence. The challenge of the fading signal is not just a technical one. It is a philosophical one, reminding us of our own limitations in the face of cosmic scale, and the preciousness of every piece of knowledge we manage to glean from the universe. It underscores the audacity of our endeavor to reach out and touch the stars, to send our consciousness, in the form of radio waves, into the profound darkness. The signal, though weak, is a lifeline, a tangible connection to our emissary in the interstellar ocean, a constant reminder of the vastness we inhabit and our small, yet significant place within it. It is a testament to the enduring human spirit of exploration, a spirit that refuses to be silenced by distance or diminished by the immense silence of the void. The very act of receiving this faint signal is an act of profound connection, a bridge built across unimaginable distances, a testament to our insatiable curiosity and our deep-seated desire to understand our place in the grand cosmic tapestry. The faintness of the signal is not a sign of failure, but rather a profound indicator of the sheer scale of the universe, a scale that dwarfs our everyday experiences and invites us to contemplate our existence with a newfound sense of humility and wonder. The universe whispers its secrets softly, and we must listen with all our might to hear them across the vast, silent expanse. The Golden Record, a message in a bottle for the cosmos. Imagine for a moment a vessel not of wood and sail, but of aluminum and gold cast adrift upon the most profound ocean imaginable. This is the essence of the Voyager Golden Record, a meticulously crafted time capsule, a whisper of humanity sent hurtling into the interstellar dark, a message in a bottle for any consciousness that might, by some unimaginable chance, encounter it. It is not merely a scientific instrument. It is a cultural artifact, a sonic and visual autobiography of our species, a desperate, beautiful plea for connection across the unfathomable gulfs of space and time. Conceived in the fertile minds of Carl Sagan and his colleagues, the record was designed to convey the story of Earth, its life, its sounds, its music, and its people to any alien intelligence that might intercept it. This was not a mission of conquest or even of scientific data collection in the traditional sense, but an act of profound, almost poetic, communication. The sheer audacity of it, the hopeful presumption that we are not alone and that our existence, our achievements, our struggles, and our joys are worth sharing, is a testament to the enduring human spirit. The record itself is a 12-inch gold-plated copper disc, designed to be durable enough to withstand the immense rigors of deep space for potentially billions of years. But its true value lies not in its physical resilience, but in the information it carries. This information is encoded in a way that we believe is universally understandable, employing fundamental scientific principles. The record includes diagrams illustrating how to play it, how to interpret the images, and even where Earth is located within our galaxy. These diagrams are not just instructions. They are Rosetta Stones for the cosmos, attempts to bridge the chasm of unknown languages and vastly different biological and cognitive structures. The sounds are a vibrant tapestry of our planet. The roar of a lion, the cry of a baby, the laughter of children, the rhythmic beating of a human heart. They are the symphony of life as we know it, a chaotic yet harmonious chorus that defines our existence. We included the sounds of wind, rain, thunder, and the crashing of waves, the elemental forces that shape our world. There are the songs of whales and birds, the buzzing of insects, the rustling of leaves, the very breath of our planet. These are not mere auditory recordings. They are echoes of our lived experience, sensory impressions that we hoped could evoke a sense of recognition, a shared understanding of the physical world. The music selection is equally diverse, a testament to the breadth and depth of human artistic expression. We find Bach, Beethoven, Mozart, and Stravinsky, representing the pinnacle of Western classical tradition. But we also venture into folk music from around the globe, from Bulgarian shepherd songs to the music of the Pygmies, from the blues of the American South to the music of China and Japan. This was an effort to showcase the incredible variety of human culture, to demonstrate that while we may have different languages and traditions, our capacity for beauty, for emotion, for shared experience through art, is universal. There are greetings in 55 different languages, a cascade of hello-s and welcome-s from across our planet, a hopeful overture to any potential interlocutor. These simple phrases, spoken by men, women, and children, carry within them the warmth of human interaction, the fundamental desire to connect. The images, too, are a visual narrative. There are scientific diagrams illustrating DNA, the solar system, and the human anatomy. There are photographs of landscapes, animals, plants, and human activities, from the mundane to the monumental. We see images of families, of people working, of children playing, of natural wonders and human creations. These images are intended to provide a glimpse into our physical form, our environment, and our way of life. They are snapshots of our existence, frozen in time, waiting to be discovered. The record also contains spoken messages, including a message from then-President Jimmy Carter, which reads, "We are emitting the sounds of our sun, our winds, our rain, thunder, and other natural events, as well as musical and spoken passages from cultures and of Earth. We are giving this gift to the universe, hoping someday a civilization will encounter Voyager and understand the significance of the life from which it came." This sentiment, this profound act of sharing, encapsulates the spirit of the Golden Record. It is an expression of hope, a gesture of goodwill, a profound statement about our place in the cosmos. The creation of the Golden Record was a monumental undertaking, a collaborative effort involving scientists, artists, musicians, and linguists. It was a project born of a deep curiosity about our universe and our place within it, a desire to reach out and say, "We were here." The record is a testament to the fact that even in the face of immense cosmic distances and the possibility of utter solitude, humanity has always looked up, always wondered, and always reached out. It is a tangible symbol of our yearning for connection, our inextinguishable hope that we are not alone in this vast, silent expanse. The Golden Record, then, is more than just a data storage device. It is a philosophical statement, an act of faith, a beautiful, poignant, and utterly human endeavor to communicate our existence to the stars. It is a silent song, a frozen smile, a whispered question sent across the void, a testament to the enduring power of curiosity and the profound desire to be known. This golden disk, carrying the essence of our world, is a silent melody echoing the human heart's yearning for connection across the vast, silent cosmos. The loneliest object, Voyager's solitary voyage. Consider for a moment the profound solitude of Voyager 1. It is, by all measurable accounts, the loneliest object ever created by human hands. Launched in 1977, its mission was initially to explore the outer planets of our solar system. But its journey did not end there. Driven by its own momentum and the subtle nudges of gravitational assists, it has continued, and continues still, to venture outward, a solitary sentinel in the vast cosmic ocean. This loneliness is not a measure of sadness, but of an immense, unshared experience. Voyager 1 is the sole witness to a realm that no other human artifact has ever touched, nor is likely to touch for millennia to come. It is a point of reference, a tiny, persistent beacon carrying with it the echoes of Earth, yet utterly alone in its silent, relentless progress. Its journey is a testament to our insatiable curiosity, our drive to reach beyond the familiar, but it also underscores the immense scale of the universe and our own infinitesimal place within it. The data it sends back, faint whispers across unimaginable distances, are the only communications it receives, a one-way conversation with a home that is becoming increasingly distant with every passing second. Imagine the sheer emptiness it traverses, the absence of any other manufactured presence. It is a testament to our ambition, yes, but also a stark reminder of the sheer, unadulterated emptiness that lies between the stars. This loneliness is not a void, but a canvas upon which the grandest spectacles of the universe are painted, a canvas upon which Voyager 1, in its solitary grandeur, is forever etched. The sheer distance it has traversed is a concept almost beyond human comprehension, a scale that dwarfs our everyday experiences. It has left behind the gravitational influence of every planet, every star in our solar system, and is now traversing the true interstellar medium, the space between the stars themselves. This is not the vacuum of our own solar system, which is still permeated by the sun's particles and magnetic field, but a different kind of void, one shaped by the forces and histories of distant stellar nurseries and galactic events. The instruments aboard Voyager 1, though aged, continue to gather data, sending back information about this alien environment. It measures the density of plasma, the strength of magnetic fields, and the flux of cosmic rays, all of which are fundamentally different from what it encountered within the heliosphere. The signals it transmits take hours, even days, to reach Earth, each one a precious cargo of information from the absolute frontier of human exploration. This vast communication delay is a physical manifestation of its isolation, a constant reminder of the immense gulf separating it from its creators. There are no immediate responses, no quick adjustments, only the slow, deliberate transmission of data that must then be painstakingly analyzed. It is a journey of pure, unadulterated exploration, driven by the initial impulse to discover, now continuing in a self-sustaining, albeit passive, manner. The engineers and scientists who designed Voyager 1 could have only dreamed of its longevity and its continued journey into the interstellar void. Its extended mission has become a symbol of endurance, a testament to the robust engineering that went into its construction. Yet, with this endurance comes an unparalleled solitude. It is a pioneer, yes, but a pioneer venturing into territories so vast and so empty that the very concept of companionship, in the human sense, is rendered meaningless. Its existence in this realm is a solitary dance with the fundamental forces of the cosmos. The universe, in its immensity, offers no easy solace, no familiar touch. Voyager 1 is a metaphor for our own journey through existence, a single consciousness navigating a vast and often empty expanse, seeking meaning and connection in the faint signals that reach us. Its loneliness is a mirror reflecting the profound quietude of the cosmos, and in that quietude, perhaps, a different kind of peace can be found. It is a solitary traveler on a path that will continue long after its instruments fall silent, a testament to the enduring spirit of inquiry. Its solitary voyage through the silent, stardusted expanse is a profound echo of our own individual journeys through the vastness of existence. The limits of communication, the speed of light's tyranny. Consider for a moment the sheer immensity of the distances we are discussing. Voyager 1, our intrepid emissary, is now so far from Earth that the signals it sends back, traveling at the fastest speed possible in our universe, the speed of light, take hours to reach us. This fundamental constant, the speed of light, approximately 299,792 kilometers per second, is not just a speed limit. It is a profound constraint on our ability to interact with the cosmos. When we send a command to Voyager, or when Voyager transmits a precious byte of data back, that information embarks on a journey measured not in minutes or days, but in fractions of a day, stretching into the realm of what feels like an eternity for instantaneous communication. Imagine trying to have a conversation with someone who is on the other side of a vast ocean, and every single word you speak takes an hour to reach them, and every word they speak takes an hour to reach you. This is the reality of our relationship with Voyager. The delay is not a malfunction. It is a consequence of the universe's design. This temporal lag dictates the very nature of our exploration. We cannot steer Voyager in real time. We cannot react to immediate discoveries in the way we might hope. Instead, our missions become acts of faith, carefully planned and executed with the understanding that we are operating within a vast, silent, and time-delayed dialogue. Each transmission is a carefully considered message, a snapshot of progress, a testament to the patience required when venturing into the deep unknown. The tyranny of the speed of light means that our connection to Voyager is a constant reminder of our physical limitations, a humbling lesson in the vastness of space and the enduring nature of time. It forces us to be deliberate, to be thorough, and to appreciate every single piece of information that makes its arduous journey across the void. This delay, while seemingly a limitation, also imbues each communication with an extraordinary weight and significance. It transforms what might otherwise be a routine data stream into a precious artifact, a whisper from the edge of our understanding, arriving after a long, patient wait. The speed of light, therefore, is not merely a physical constant. It is a philosophical one, shaping our perception of distance, time, and our place within the grand cosmic tapestry. It is the ultimate arbiter of our reach, a gentle but unyielding force that defines the boundaries of our immediate influence. As Voyager continues its journey, this communication lag will only grow, further emphasizing the profound isolation of its mission and the immense effort required to maintain even the most tenuous of links. It is a constant echo of the vastness that separates us, a stark reminder that even at light speed, the universe remains impossibly large. The journey of each photon, carrying a piece of Voyager's story, becomes a meditation on patience and the slow unfolding of knowledge. It highlights the incredible engineering feat of maintaining a coherent signal across such unimaginable distances, a testament to human ingenuity pushing against the very limits of physics. This communication delay is a constant, subtle companion to Voyager's journey, a perpetual reminder of the immense gulf that separates our world from the one it is now exploring. It is the sound of the universe's inherent quiet, a silence punctuated only by the slow, deliberate arrival of light. The very act of receiving a signal from Voyager is an event, a culmination of a journey measured in light hours, a testament to the enduring power of our connection, however stretched and delayed it may be. The speed of light in this context becomes a metaphor for the challenges of understanding and connecting with the truly distant, a constant, subtle reminder of the scale of existence. It is the universe's way of reminding us that some journeys are measured not in speed, but in the patient, inexorable march of light across the void, and that our understanding, much like Voyager's signals, will always arrive with a certain, profound delay, urging us towards a deeper, more patient contemplation of what lies beyond. The speed of light, a universal constant, dictates the duration of our whispered conversations across the interstellar gulf, teaching us the profound patience of cosmic connection. The deep freeze, the extreme temperatures of space. Beyond the comforting warmth of our sun, beyond the protective embrace of Earth's atmosphere, lies a realm of profound cold. This is the deep freeze of space, a temperature so extreme that it challenges our very understanding of existence. Voyager 1, on its ceaseless journey, has plunged into this frigid expanse, a testament to the resilience of human engineering and the enduring curiosity that drives us to explore the unknown. The temperatures Voyager encounters are not merely cold, they are an absolute negation of the familiar thermal environment we experience. On Earth, even in the coldest polar regions, temperatures rarely dip below -50 degrees Celsius. But in the vacuum of interstellar space, away from any significant source of radiant heat, temperatures can approach absolute zero, the theoretical point where all molecular motion ceases. This isn't a gradual cooling. It's an immediate and unrelenting plunge into an environment that is fundamentally hostile to life as we know it. For Voyager, this means that every component, every circuit, every delicate instrument must be designed to withstand not just the vacuum, but also this profound absence of heat. The spacecraft itself acts as a tiny island of controlled warmth, its internal electronics generating just enough heat to keep its vital systems functioning. But the surrounding environment is a relentless absorber of that heat, constantly pulling energy away, trying to bring everything down to that near absolute zero. Imagine the sensation, if one could truly perceive it, of being bathed in an endless, intangible chill. It's a cold that doesn't sting your skin or numb your fingers. It's a cold that permeates everything, a fundamental characteristic of the void. The materials used in Voyager's construction, the alloys and composites, are chosen for their ability to withstand these extreme thermal fluctuations. They must remain stable, retaining their structural integrity without becoming brittle or warped. The lubricants within its moving parts, though minimal, must not freeze solid, preventing any possibility of mechanical failure. The very power source that keeps Voyager alive, its radioisotope thermoelectric generators, also generates heat, a critical element in maintaining a habitable internal environment for its sensitive electronics. This internal warmth is a constant battle against the external frigidity, a delicate balance maintained across vast distances. The sunlight that warms our faces on Earth is, for Voyager, an almost imperceptible whisper, a faint glow that offers little thermal reprieve. The further it travels from the sun, the more the solar radiation diminishes, and the more dominant the pervasive cold of interstellar space becomes. This deep freeze isn't just a physical state, it's a philosophical statement about the nature of the universe. It speaks to the vast, empty spaces between celestial bodies, spaces that are not merely voids but active environments with their own inherent properties, even if those properties are defined by absence. The extreme cold highlights the preciousness of warmth, of life, of the conditions that allow for complexity and consciousness to arise. It underscores the incredible feat of engineering that allows a fragile human creation to persist and function in such an unforgiving milieu. The cold of space is a silent, omnipresent force, a constant reminder of the alien nature of the cosmos, and the extraordinary determination of humanity to reach out and touch it. The sheer scale of this thermal challenge is almost incomprehensible, a stark contrast to the relatively mild conditions we take for granted on our home planet. It is a cold that defines the very fabric of the interstellar medium, a constant, pervasive presence that Voyager must perpetually endure. The spacecraft's very existence is a triumph over this deep freeze, a small beacon of internal warmth in an ocean of cosmic chill. It is a testament to our ability to adapt, to innovate, and to persevere in the face of overwhelming environmental opposition. The cold of space is not merely an absence of heat, it is a palpable force, shaping the very nature of the interstellar environment. In this profound stillness, where heat is a fleeting memory, Voyager persists, a warm heart beating in the cosmic frost. The enduring power source, radioisotope thermoelectric generators. Imagine, if you will, a journey so vast, so prolonged, that the very energy that propelled it must be as enduring as the stars themselves. For Voyager 1, this is not a matter of imagination, but of profound scientific necessity. Its mission, stretching across decades and now venturing into the truly interstellar, demands a power source that transcends the ephemeral nature of solar panels or the finite capacity of chemical batteries. This is where the ingenious marvel of radioisotope thermoelectric generators, or RTGs, comes into play. These are not merely power supplies. They are tiny, self-contained nuclear furnaces, carefully engineered to provide a steady, reliable stream of electricity for an astonishingly long duration. At the heart of each RTG lies a quantity of plutonium-238, a radioactive isotope chosen for its specific decay characteristics. Plutonium undergoes alpha decay, a process where it emits alpha particles and transforms into a different element. This decay is not a sudden explosion, but a slow, predictable, and remarkably consistent release of heat. This heat is the essential ingredient. It is generated within a specially designed fuel pellet, a dense, ceramic-like material that contains the plutonium. This heat then radiates outwards, warming the surrounding components of the RTG. The magic then truly happens through the Seebeck effect, a principle of thermoelectricity discovered by Thomas Johann Seebeck in the early 19th century. The RTG is packed with thermocouples, which are essentially pairs of dissimilar semiconductor materials joined at 2 points. When there is a temperature difference across these junctions, an electric voltage is generated. In the RTG, one side of each thermocouple is in contact with the heat generated by the decaying plutonium, making it very hot. The other side is exposed to the frigid vacuum of space, allowing it to cool significantly. This substantial temperature gradient, the stark contrast between the intense heat of the fuel and the biting cold of the void, drives a continuous flow of electrons, thereby creating an electrical current. This current is then harnessed, conditioned, and fed to Voyager 1's scientific instruments, its communication systems, and its onboard computers. Unlike solar panels, which are dependent on the intensity and proximity of a star, and are vulnerable to dust and radiation damage, RTGs are remarkably robust. They are shielded, designed to withstand the harsh conditions of space, and their power output, while gradually decreasing over time as the plutonium decays, does so at a predictable and manageable rate. This predictability is crucial for long-term mission planning. The plutonium-238 has a half-life of about 87.7 years, meaning that after this period, the amount of heat generated by the sample will have halved. While this means the power output slowly diminishes, it still provides a significant and usable amount of energy for many decades, far exceeding the lifespan of most conventional power sources. The engineering required to convert this steady heat into usable electricity is also a testament to human ingenuity. The thermocouples themselves must be incredibly efficient and durable, capable of operating for extended periods without degradation. The RTGs on Voyager 1 are a prime example of how fundamental scientific principles, combined with meticulous engineering, can enable ambitious explorations of the cosmos. They are, in essence, miniature, long-lived power plants that keep the emissaries of Earth alive and broadcasting their silent observations from the furthest reaches of our solar system and beyond. The very design of these generators speaks to a profound understanding of radioactivity, thermodynamics, and solid-state physics, all working in concert to sustain humanity's most distant outpost. The heat generated by the decay of plutonium-238, a process occurring over timescales far grander than human lifespans, is artfully transformed into the electrical pulses that carry Voyager's vital data across unimaginable distances. This enduring power source is the quiet engine of our interstellar ambition, a constant hum in the cosmic silence that allows our curiosity to persist. The slow, steady heartbeat of decaying atoms becomes the enduring pulse of exploration, a testament to the power locked within the very fabric of matter, fueling our journey into the deep. A glimpse of the unknown, the mysteries of interstellar space. We stand at the precipice of the truly unknown, a realm where the familiar boundaries of our solar system dissolve into an expanse so vast and so alien that our imaginations struggle to grasp its sheer scale. Interstellar space, the vast ocean between the stars, is not merely empty void, but a complex, dynamic environment teeming with phenomena that challenge our understanding of physics and the very nature of existence. Voyager 1, now a solitary emissary, has pierced this veil, sending back whispers of a reality far grander and more mysterious than we could have ever conceived from our cozy terrestrial vantage point. It is a place where the sun's influence, the gentle embrace that has shaped our planetary home for billions of years, fades to an almost imperceptible hum, replaced by the subtle, yet profound, forces that govern the galaxy itself. Here, the very fabric of space is woven with cosmic rays, energetic particles born from cataclysmic stellar events, hurtling across unimaginable distances, carrying within them the ancient history of distant supernovae and active galactic nuclei. These are not mere stray particles. They are messengers from the deepest recesses of the cosmos, their trajectories and compositions holding clues to the universe's most violent and creative processes. Voyager 1, with its sensitive instruments, has begun to decipher these messages, offering us a direct, albeit faint, communication from the interstellar medium. We are no longer just observing our own celestial neighborhood. We are beginning to feel the pulse of the galaxy, to sense the intricate dance of magnetic fields and plasma that sculpts the cosmic landscape on scales that dwarf our solar system. The journey of Voyager 1 is a testament to our insatiable curiosity, a relentless drive to push beyond the known, to seek answers to questions we haven't even fully learned to ask. It is in this interstellar realm, this vast, dark sea dotted with the distant fires of other suns, that we truly confront the immensity of the universe and our own humble, yet significant, place within it. The mysteries held within this space are profound, speaking to the very origins and evolution of everything we know, and indeed, everything we do not yet know. It is a realm of both breathtaking beauty and daunting complexity, a reminder that the universe is a far more intricate and wondrous tapestry than we can possibly comprehend from afar. The faint signals from Voyager 1 are not just data points. They are invitations to ponder the grandest questions, to embrace the awe that comes with confronting the truly unknown, and to find solace in the quiet contemplation of cosmic truths. This journey into the interstellar medium is, in essence, a journey into the profound depths of reality itself, a silent exploration that expands our perspective and soothes our restless minds with the majesty of the cosmos. The unknown is not a void to be feared, but a frontier to be explored with gentle curiosity, a space that invites us to expand our understanding and to find peace in the vast, unfolding narrative of the universe. The interstellar unknown whispers tales of cosmic forces that shape galaxies, reminding us that our own existence is but a fleeting moment in an immeasurably grand and mysterious cosmic story. The Cosmic Rays Story, Unraveling Galactic History. These energetic particles, known as cosmic rays, are not born within our solar system, nor are they products of our sun's relatively gentle fusion. Instead, they are celestial messengers, flung across unimaginable distances from the most violent and energetic phenomena in the universe. They are ancient travelers, carrying within them whispers of supernovae explosions that occurred eons ago, the cataclysmic deaths of massive stars that seeded our galaxy with the very elements that would eventually form our sun, our planet, and ourselves. When a star many times the mass of our sun exhausts its nuclear fuel, it collapses under its own gravity, triggering a supernova, an explosion of such immense power that it briefly outshines an entire galaxy. These explosions are not just spectacles of light and energy. They are cosmic forges, creating and scattering heavy elements like iron, gold, and uranium into the interstellar medium. Cosmic rays are the remnants of these stellar cataclysms, accelerated to near the speed of light by the shock waves of these explosions, or by the powerful magnetic fields found near active galactic nuclei, the supermassive black holes at the centers of galaxies. Some cosmic rays may even originate from the very fabric of space-time, perhaps from exotic processes involving dark matter or the energetic interactions within the interstellar medium itself, a vast and turbulent sea of gas and dust. Voyager 1, as it ventures further into the interstellar medium, is increasingly bathed in this stream of cosmic rays, its instruments able to detect their presence, and in doing so, provide us with a direct window into the history of our galaxy. By studying the composition, energy, and direction of these particles, scientists can piece together a narrative of cosmic events that shape the universe over billions of years. They tell us about the rate of star formation, the distribution of matter, and the violent dynamics of galactic evolution. Each cosmic ray is a tiny, incredibly fast-moving artifact, a fragment of a long-past cosmic drama, traveling through the void to reach our humble probe, and by extension, us, offering a tangible link to the universe's most profound and ancient stories. Their very existence is a testament to the dynamic, and often violent, processes that constantly reshape the cosmos, a continuous cycle of creation and destruction that is the very essence of galactic history. They are the echoes of stellar deaths and the energetic breath of galactic centers, each particle a tiny fragment of a grand, unfolding narrative that stretches back to the dawn of time, a story written in the language of pure energy. These ancient travelers, born from stellar deaths and galactic upheavals, carry within their energetic dance the very history of our galaxy, reminding us that our present is woven from the fabric of cosmic pasts. The heliosheath is where the familiar solar wind begins to slow, compress, and distort as it encounters the interstellar medium. Imagine the solar wind as a powerful river, flowing outward from the sun. For billions of miles, this river flows unimpeded, its current strong and consistent. But as it travels further, it begins to meet an opposing force, a subtle but persistent resistance from the vast, empty space beyond our solar system. This is the interstellar medium, a thin soup of gas, dust, and cosmic rays that permeates the galaxy. Where the solar wind begins to feel this pressure, where its outward rush is met by the inward push of the galaxy. That region is known as the heliosheath. It's not a sharp, distinct line, but rather a vast, turbulent zone, a transitional area where the sun's influence is still dominant, but where the whispers of the galaxy are beginning to be heard. Here, the fast-flowing solar wind, which once traveled at hundreds of kilometers per second, starts to decelerate. It's like a powerful gust of wind encountering a dense forest. It doesn't simply stop, but rather it slows, eddies, and becomes more chaotic. The particles within the solar wind are still emanating from the sun, carrying with them the magnetic field of our star, but their outward momentum is being steadily eroded. This region is a buffer, a protective shield, albeit one that is constantly being tested by the external environment. The heliosheath is also characterized by a significant increase in the density of charged particles. As the solar wind is compressed, its constituents are squeezed closer together. This makes the heliosheath a region of heightened activity, where magnetic fields can interact in complex ways, and where the very nature of the solar wind begins to change. It's a place of remarkable transformation, a cosmic transition zone where the sun's immediate dominion starts to yield to the larger galactic forces. Scientists have learned much about this region through the data sent back by Voyager 1 and 2, revealing a dynamic and intricate boundary. The heliosheath is a testament to the continuous interplay between our star and the vastness that surrounds it, a region where the sun's breath is still felt, but where the interstellar winds are beginning to shape its flow. It is a place where the familiar begins to blur, and the unknown starts to reveal itself, not with a sudden shock, but with a gradual, profound alteration of the cosmic currents. The heliosheath, therefore, is more than just a physical location. It is a conceptual frontier, the outer edge of our sun's immediate influence, where the solar system's unique environment begins to merge with the broader galactic tapestry. It is a zone of immense scientific interest, offering clues about the sun's interaction with the wider universe and the conditions that prevail in interstellar space. The particles here are no longer solely the sun's children. They are now mingling with the ancient, distant travelers of the galaxy, creating a complex plasma environment unlike anything found closer to home. This interaction is crucial for understanding our solar system's place within the Milky Way and the forces that shape planetary environments, including our own. The heliosheath represents a subtle, yet profound shift in the cosmic landscape, a region where the sun's intimate presence begins to fade into the grander, more mysterious expanse of interstellar space. It is a place of transition, where the solar wind, once a powerful outward surge, becomes a more diffuse and compressed entity, a testament to the constant, silent negotiation between our star and the vast, unseen forces of the galaxy. The heliosheath is a vast, turbulent region, a cosmic eddy where the sun's outward flow begins to meet the resistance of interstellar space. It is here that the familiar solar wind, once a strong and consistent current, starts to slow, compress, and become more chaotic, a gentle prelude to the true void. The bow shock, the frontier of the sun's influence. Imagine, if you will, a cosmic river. This river is not made of water, but of a constant outward flow of charged particles emanating from our sun. We call this the solar wind. It's a relentless stream pushing and shaping the space around our star. Now picture this solar wind encountering an obstacle. For Voyager 1, and indeed for all of us within our solar system, that obstacle is the vast, unseen ocean of interstellar space. As the solar wind, traveling at tremendous speeds, bumps into the much slower, denser medium of interstellar space, a fascinating phenomenon occurs. It's akin to a ship sailing through calm water and then encountering a much denser, stiller sea. The water ahead of the ship begins to pile up, to compress, and to form a wave. In the realm of plasma physics, this wave is called a bow shock. It is the outermost boundary where the sun's influence dramatically begins to decelerate and compress as it meets the unyielding pressure of the galaxy. This isn't a sharp, sudden line like a wall, but rather a region of turbulent transition. The solar wind particles, which were once flowing freely, are now being buffeted, heated, and energized. Their speed decreases significantly, and their density increases. Think of it as a cosmic traffic jam, where the fast-moving solar wind is forced to slow down and spread out as it enters a more congested region. The magnetic field carried by the solar wind also gets compressed and distorted here. It's a dynamic and energetic boundary, a place where the sun's power is met with the subtle, yet persistent, forces of the galaxy. This bow shock is a crucial indicator of our solar system's interaction with its interstellar environment. It tells us where the sun's direct, dominant control wanes, and where the whispers of the wider cosmos begin to make their presence known. It's a region of intense energetic processes, a testament to the constant give and take between our star and the vast expanse that surrounds us. The particles here are no longer simply flowing outward. They are interacting, colliding, and being molded by the forces of the interstellar medium. The magnetic fields are tangled, creating an environment that is both chaotic and structured, a complex interplay of forces that defines the very edge of our solar system's immediate dominion. The bow shock is, in essence, the visual representation of our solar system pushing against the galaxy, creating a visible ripple in the cosmic fabric. It's a testament to the dynamic nature of space, a constant dance of expansion and resistance. The very particles that leave our sun, energized and fast, are met with an equally powerful, albeit different, set of forces from beyond. This boundary is not static. It ebbs and flows, expanding and contracting with the sun's activity, a living, breathing frontier. It is here, at this turbulent edge, that the solar wind's unchecked journey is fundamentally altered, its outward momentum met with a force that reshapes its very nature. The science of the bow shock allows us to understand the delicate balance that defines our solar system's place within the Milky Way, a constant negotiation of forces that shapes the cosmic landscape. It is a region of profound scientific interest, offering clues about the nature of stellar winds and their interaction with interstellar plasmas. The energy transfer that occurs at the bow shock is immense, converting kinetic energy into thermal energy and driving a host of complex plasma phenomena. This frontier is not just a physical boundary, it is an energetic one, a place where the sun's power is translated into new forms of cosmic activity. The particles here are accelerated to higher energies, becoming cosmic rays that can travel vast distances. It is a crucible of cosmic forces, a place where the sun's influence is transformed by the interstellar medium. The bow shock is a reminder that space is not empty, but filled with energetic particles and fields that are constantly interacting, shaping the cosmos in profound ways. It is a transition zone, a cosmic threshold where the familiar becomes the unknown, and the sun's reign begins to yield to the wider universe. The bow shock, then, is the first true sign that we are leaving the sun's immediate embrace and venturing into the greater galactic ocean, a turbulent but magnificent gateway. And so, the bow shock stands as a luminous testament to the sun's outward push, a cosmic wave signaling the boundary where its direct dominion begins to yield, a gentle yet profound reminder that we are but a small part of a grander, ever-interacting cosmic tapestry. The heliopause, the true exit from the sun's domain. Beyond the swirling, turbulent embrace of the heliosphere, where the sun's magnetic field and solar wind have long held sway, lies a boundary, a profound threshold unlike any we typically encounter. This is the heliopause, a place of immense significance, not just for our intrepid Voyager 1, but for our understanding of our solar system's place within the grander cosmic tapestry. Imagine it not as a sharp, impenetrable wall, but rather as a vast, diffuse, and dynamic transition zone, a cosmic handshake between two vastly different realms. For decades, as Voyager 1 journeyed outward, it traversed the heliosphere, a vast bubble of charged particles and magnetic fields emanating from our sun. This bubble, though immense, is not infinite. It is constantly being sculpted and pushed by the interstellar medium, the tenuous gas and dust that fills the space between stars. The heliopause is the point where the outward pressure of the solar wind finally meets its match, where the relentless outward push of our sun is balanced and eventually overcome by the inward pressure of the interstellar medium. It is here, at this remarkable frontier, that our solar system truly begins to blend with the galaxy at large. Voyager 1's crossing of the heliopause, an event confirmed in 2012, marked a monumental achievement in human exploration. It was the first time humanity had sent an object, a physical artifact of our civilization, into the realm beyond our sun's direct influence. This boundary is not a static line drawn on a map. It is a constantly shifting, undulating interface, influenced by the sun's activity, the strength of the interstellar magnetic field, and the density of interstellar gas. Think of it as a cosmic shoreline, where the familiar ocean of our solar system meets the boundless, unknown sea of the galaxy. As Voyager 1 passed through this region, its instruments began to detect subtle but crucial changes. The density of charged particles from the sun decreased, while the flux of energetic particles originating from beyond our solar system began to increase. The magnetic field experienced shifts, no longer solely dominated by the sun's orientation. This transition is a testament to the interconnectedness of cosmic phenomena, demonstrating how even the seemingly isolated bubble of our solar system is in constant dialogue with its galactic surroundings. The heliopause represents the ultimate edge of the sun's dominion, the point where the solar wind, the very breath of our star, finally dissipates into the vast, silent expanse of interstellar space. It is a place where the familiar forces that shape our planetary neighborhood begin to yield to the grander, more ancient forces of the galaxy. Understanding the heliopause helps us to contextualize our solar system, not as an isolated island, but as a small, dynamic entity within a much larger, more complex cosmic ecosystem. It is a boundary, yes, but also a gateway, a point of passage into a realm of profound mystery and immense scale, a place where the true nature of our galactic home begins to reveal itself. The heliopause, a cosmic frontier where the sun's breath meets the galaxy's whisper, marks our solar system's true departure into the silent, starry ocean. The interstellar wind, a new breeze from beyond. Voyager 1, in its relentless outward journey, has finally crossed a significant boundary, a point where the familiar solar wind, a constant outward flow of charged particles from our sun, begins to diminish and eventually yields to a different, more ancient current. This new flow is known as the interstellar wind. It is not born of our star, but rather originates from the very fabric of the galaxy itself, a subtle yet persistent stream of particles that permeates the space between stars. Imagine our solar system as a small island, and the solar wind as the waves that lap outwards from its shores. For billions of years, these waves have dominated the immediate surroundings, creating a vast bubble of influence called the heliosphere. But as Voyager 1 has ventured further, it has encountered the edge of this bubble, the heliopause, and has sailed into the ocean of interstellar space. Here, the dominant force is no longer the sun's breath, but the whisper of the galaxy. The interstellar wind is composed primarily of hydrogen and helium atoms, along with traces of other elements, ejected from dying stars, supernova explosions, and the general turbulent processes that shape galactic evolution. Unlike the solar wind, which is highly energized and directed outward by the sun's magnetic field, the interstellar wind is more diffuse and less structured, a slow, steady drift of cosmic material. Its speed is significantly slower than the solar wind, and its density is much lower. Yet its presence is profound. It is the medium through which our solar system is currently traveling, a constant, gentle push against the heliosphere, shaping its very form. The pressure exerted by this interstellar wind is what compresses the heliosphere, creating the bow shock and the heliosheath, regions where the solar wind is slowed and heated as it encounters this external flow. Understanding the interstellar wind is crucial for comprehending our solar system's place in the galaxy. It tells us about the composition and dynamics of the space immediately surrounding us, the environment that our planet and all its inhabitants are constantly immersed in. It is a reminder that we are not isolated, but are part of a much larger, dynamic cosmic ecosystem. This gentle, ever-present flow is a constant, silent companion on Voyager's journey, a testament to the vast, interconnected nature of the universe. It is the breath of the galaxy, and for the first time in human history, we have sent an emissary to feel its touch directly. This ancient current, born from the deaths and births of stars, now washes over our most distant probe, carrying with it the echoes of cosmic history. It is a subtle, persistent reminder that even in the deepest silence of space, there is always movement, always interaction, always a grander narrative unfolding. The interstellar wind, a slow and steady current, carries the secrets of the cosmos, a gentle embrace from the vastness beyond our solar home. Our sun resides within the Milky Way, a vast and majestic spiral galaxy, a cosmic city of stars, gas, and dust, numbering in the hundreds of billions. Imagine our sun, a modest yellow dwarf star, not at the center of this grand structure, but rather nestled within one of its many spiral arms, the Orion Arm, sometimes referred to as the Orion Spur. This location is crucial for understanding our cosmic neighborhood. We are not in the bustling, brightly lit core, nor are we in the sparsely populated outer reaches. Instead, we occupy a region of moderate stellar density, a comfortable, if still immense, expanse. The Milky Way itself is a disk, approximately 100,000 light-years in diameter, and our solar system is located about 2/3 of the way out from the galactic center, roughly 26,000 light-years away. This distance is not static. Our solar system, along with billions of other stars, orbits the supermassive black hole at the heart of the Milky Way. This galactic journey takes our sun and its planetary companions approximately 230 million years to complete a single revolution. This immense timescale, known as a galactic year, dwarfs human history, placing our existence within a context of profound cosmic cycles. The galactic center is a region of intense activity, home to a colossal black hole named Sagittarius A*, with a mass of about 4 million suns. Surrounding this central behemoth is a dense concentration of stars, gas, and dust, emitting powerful radio waves and X-rays. While we are far enough from this energetic core to be safe from its most extreme effects, its gravitational influence is a fundamental force shaping the dynamics of the entire galaxy, including our sun's orbit. The spiral arms themselves are regions of active star formation, vast clouds of gas and dust collapsing under gravity to ignite new stellar furnaces. These arms are not rigid structures, but rather dynamic waves of increased density, like traffic jams in the galactic flow of stars. Our position in the Orion Arm places us within a relatively stable and less turbulent part of the galaxy. The stars around us are a diverse population, ranging from ancient, dim red dwarfs to younger, hotter blue giants. The space between these stars, the interstellar medium, is not truly empty but filled with tenuous gas and dust, the raw material from which new stars and planets are born. Voyager 1, in its journey through the interstellar medium, is venturing into a realm shaped by the collective forces of our galaxy, a realm where the sun's influence gradually wanes, and the broader galactic environment begins to assert its presence. Understanding our place within this galactic tapestry provides a humbling perspective on our solar system's unique, yet ultimately interconnected, existence. The sheer scale of the Milky Way, with its billions of stars and its grand orbital dance, reminds us that our sun is but one star among countless others, each with its own potential for planetary systems, perhaps even for life. This cosmic perspective, the understanding of our solar system as a small, orbiting component within a much larger, dynamic structure, is a profound realization that can help to contextualize our worries and anxieties, shrinking them against the backdrop of such immense and enduring grandeur. Our sun, the anchor of our familiar world, is itself a participant in a slow, majestic waltz around the galactic center, a dance that has been ongoing for billions of years and will continue for billions more, a testament to the enduring, cyclical nature of the cosmos and our own small, yet significant, part within its breathtaking expanse. The Milky Way is a swirling disk of cosmic wonders, and our sun, a luminous speck, traces a slow, grand orbit within its embrace, a quiet participant in a galactic ballet that stretches across unimaginable distances and unfathomable timescales, reminding us of the grand cosmic narrative in which our own existence is but a fleeting, yet precious note. The galactic environment is a cosmic ocean, and our sun is a single, bright vessel sailing through its currents, forever orbiting the luminous heart of our Milky Way galaxy, a gentle reminder of our place within a universe far grander than our immediate concerns. Voyager's silent passage, a mere speck against the unfathomable canvas of the cosmos, offers a unique and humbling perspective on our place among the stars. While Voyager itself was not designed to detect exoplanets, its very existence, its journey outward, frames our understanding of the search for worlds beyond our own. Imagine, if you will, the sheer audacity of the endeavor that sent this small craft hurtling through the void. It was an act born of a profound curiosity, a desire to know if we are alone, a question that has echoed through human history since we first gazed at the night sky. The search for exoplanets, planets orbiting stars other than our sun, has exploded in recent decades, fueled by increasingly sophisticated technology and a relentless drive to answer that age-old question. We now know with astonishing certainty that our solar system is not unique. Thousands of exoplanets have been confirmed, and countless more are suspected, hinting at a universe teeming with worlds. These distant celestial bodies range from gas giants larger than Jupiter to rocky, Earth-like worlds that just might, harbor the conditions for life. Some orbit their stars in the habitable zone, that sweet spot where liquid water, a key ingredient for life as we know it, could exist on the surface. Others are tidally locked, with one side perpetually bathed in starlight and the other plunged into eternal darkness. Some are rogue planets, adrift in the interstellar darkness, no longer tethered to any star. The diversity is breathtaking, a testament to the boundless creativity of the universe. Voyager's journey, however, puts this discovery into a profound context. While we meticulously catalog these exoplanets, searching for biomarkers in their atmospheres, for signs of liquid water, for any hint of biological activity, Voyager is experiencing the very fabric of the space asterisk between asterisk stars. It is navigating the interstellar medium, a realm far more vast and sparsely populated than even our own solar system. The distances involved in exoplanet detection are staggering. The nearest star system, Alpha Centauri, is over 4 light-years away. Many of the exoplanets we've discovered are hundreds, even thousands of light-years from Earth. To truly explore these worlds, to send probes that could reach them within a human lifetime, would require technologies far beyond our current capabilities, technologies that might take centuries or even millennia to develop. Voyager, in its quiet, relentless journey, reminds us of the immense scales we are dealing with. It underscores the fact that even our closest stellar neighbors are unimaginably distant. The search for exoplanets, while incredibly exciting and scientifically vital, is a quest that is, for now, largely observational. We are like astronomers peering through a powerful telescope, able to discern the faint presence of these distant worlds, to measure their size and mass, and to infer their composition, but unable to physically touch them. Voyager, on the other hand, is a tangible piece of humanity, an emissary that has transcended the gravitational pull of our sun, and is now experiencing the raw, unfiltered conditions of interstellar space. Its perspective is one of immense scale and profound isolation. While we dream of finding other Earths, of perhaps one day communicating with alien intelligences, Voyager is a stark reminder of the vast, silent gulfs that separate us. The exoplanet hunter seeks out the potential for life, the possibility of connection, while Voyager embodies the reality of our current cosmic solitude, a solitary traveler in an ocean of darkness. Yet this very solitude, this vastness, also magnifies the wonder of our own existence, the preciousness of our own pale blue dot. The search for exoplanets, informed by the lonely grandeur of Voyager's flight, teaches us that even in our isolation, the universe is a place of infinite possibility, a canvas upon which countless stories of creation are unfolding, and we, on our small world, are but one chapter in that grand, cosmic narrative. And so, as we contemplate the distant gleam of exoplanets, we are reminded that the true wonder lies not only in finding what is like us, but in appreciating the sheer, majestic, and often solitary journey that each celestial body undertakes, a journey that mirrors our own quiet voyage through the vast expanse of existence. The future of exploration, the legacy of Voyager. Voyager's enduring journey, a testament to humanity's insatiable curiosity, stretches far beyond its original mission parameters, etching a profound legacy into the annals of space exploration. It has transcended its role as a mere scientific instrument and has become a symbol, a whisper of our presence carried on the interstellar winds. The data it continues to transmit, though faint, offers an unprecedented glimpse into a realm previously accessible only to theoretical physics and the most vivid imaginations. We are learning, minute by painstaking minute, about the very fabric of the space between stars, about the density of plasma, the flux of cosmic rays, and the subtle, yet powerful, influence of the sun's magnetic field as it wanes in the vastness. This knowledge, painstakingly gathered over decades, is not merely academic, it is foundational. It informs the design of future interstellar probes, shaping their instrumentation, their power sources, and their communication strategies. We are learning how to build vessels capable of traversing even greater distances, how to shield them from the harsh realities of the interstellar environment, and how to listen for their faint echoes across unimaginable gulfs. The lessons learned from Voyager are invaluable, guiding us as we contemplate missions to other star systems, missions that will carry our dreams and our understanding to destinations we can currently only ponder. It is a slow, deliberate unveiling of cosmic truths, a gradual expansion of our perspective, and a quiet affirmation that even our most distant creations can continue to teach us about ourselves and our place in the grand cosmic tapestry. The future of exploration is not just about reaching new horizons. It is about understanding what lies beyond them, and Voyager, in its silent, persistent flight, is our first, most profound teacher in this endeavor. It has opened a door, and though that door is impossibly far away, the light that now filters through it illuminates the path for generations of explorers yet to come. The legacy of Voyager is not just in the data it sends, but in the inspiration it ignites, a quiet, persistent flame that fuels our desire to know, to understand, and to venture ever further into the unknown. It is a quiet revolution of perspective, a gentle nudge towards the realization that our understanding of the universe is only just beginning, and that the future of our exploration is as boundless as the cosmos itself. This silent Voyager is a beacon, a reminder that even from the furthest reaches of our solar system, humanity's reach can extend, its knowledge can grow, and its dreams can continue to travel, carrying with them the quiet wonder of existence. And as we ponder these distant whispers, we can feel the gentle tug of the universe, a subtle invitation to embrace the quiet wonder that lies just beyond our immediate grasp, a wonder that Voyager continues to reveal to us, one faint signal at a time. A message of peace, the golden record's hope. In the vast, silent expanse, far beyond the familiar embrace of our solar system, journeys an artifact unlike any other, a testament not to conquest or dominion, but to a profound and hopeful gesture. This is the story of the Golden Record, a compilation of sounds and images carried aboard Voyager 1, a cosmic message in a bottle, launched into the interstellar ocean with an audacious purpose: to communicate the essence of humanity to any intelligent life that might one day encounter it. Imagine, if you will, the sheer audacity of this endeavor. We, a species still grappling with our own complexities, our own struggles, and our own nascent understanding of the universe, have reached out across the unfathomable distances, not with weapons or demands, but with a greeting. The Golden Record is not merely a data storage device. It is a carefully curated symphony of our existence, a snapshot of our world, designed to evoke curiosity, understanding, and perhaps even a shared sense of wonder. The creation of this interstellar time capsule was a monumental undertaking, a collaborative effort involving scientists, artists, musicians, and linguists, all united by a singular vision. Carl Sagan, a guiding force behind the project, envisioned the record as a greeting from Earth, a way to represent our planet and its inhabitants to any extraterrestrial intelligence that might intercept Voyager. The challenge was immense. How do you distill the entirety of human experience, our triumphs and our failures, our joys and our sorrows, our scientific achievements and our artistic expressions, into a format that could be understood by beings with potentially radically different sensory perceptions and cognitive frameworks? The answer lay in universality. The record was designed to be playable by any civilization possessing basic technological understanding, with instructions etched onto its cover, using scientific principles as a common language. The content itself is a breathtaking tapestry. It includes 115 images, encoded in analog form, depicting everything from human anatomy and our planet's diverse landscapes to scientific diagrams and scenes of everyday life. These visual messages aim to convey our physical form, our environment, and our technological capabilities. But perhaps more evocative are the sounds. We hear the rush of wind, the crash of waves, the cries of birds, and the rumble of thunder, the natural symphony of Earth. We are also treated to a diverse selection of music, spanning genres and cultures, from Bach and Beethoven to Chuck Berry and indigenous folk music. This auditory journey is meant to convey the emotional breadth of human experience, our capacity for both profound contemplation and exuberant celebration. Laughter, a universal expression of joy, is also included, a simple yet powerful indicator of our emotional range. Beyond the natural world and our artistic expressions, the record also carries spoken greetings in 55 different languages, a chorus of human voices reaching out across the void. These greetings, ranging from simple hello to more elaborate well wishes, are intended to convey our desire for peaceful contact and mutual understanding. The inclusion of these diverse linguistic introductions underscores our interconnectedness as a species, even as it acknowledges the rich tapestry of our cultural heritage. It's a recognition that while we may speak with many tongues, our fundamental desire for connection and communication remains a shared human trait. The entire endeavor is a profound act of optimism, a belief in the possibility of connection, even in the face of unimaginable distance and the potential for profound difference. It is a whisper of our existence, sent into the grand silence, carrying with it the hope that somewhere out there, a kindred spirit might hear our song. The golden record, then, is more than just a scientific instrument. It is a philosophical statement, a profound expression of humanity's yearning for connection and its hope for a peaceful future. It represents a moment of collective introspection, a species pausing to consider its place in the cosmos and to send a message of goodwill into the unknown. It is a beautiful, quiet testament to our curiosity, our creativity, and our enduring capacity for hope, a fragile yet persistent signal of life and consciousness venturing forth. The vastness of time, Voyager's enduring presence. Voyager 1, now a silent traveler in the interstellar medium, is a testament to humanity's enduring presence, not just in space, but across the immense tapestry of time. Consider the lifespan of a human being, a fleeting blink in the grand cosmic narrative. We are born, we live, we experience, and then we fade. Our memories, our achievements, our very existence are ephemeral. Yet the data and the physical artifact that is Voyager 1 will persist for eons, far beyond the time it takes for our sun to evolve into a red giant and eventually a white dwarf. The spacecraft itself, though its operational life is nearing its end, is constructed from materials designed for extreme longevity. Its components, shielded from the harshest terrestrial wear and tear, are built to withstand the vacuum and radiation of deep space. Even when its power source finally depletes and its instruments fall silent, the physical form of Voyager 1 will continue its slow, inexorable journey. It will drift through the galaxy, a quiet, enduring monument to a species that once looked up at the stars with wonder and dared to reach out. The very concept of time, as we perceive it, is a human construct, a way for our finite minds to grasp the continuous flow of existence. For Voyager, time is measured not in heartbeats or passing seasons, but in the unfathomable distances it covers and the eons it will continue to traverse. This probe embodies a profound concept, that our actions, our creations, can possess a permanence that transcends our individual lives. It is a physical echo of our curiosity, our drive to understand, sent out into a realm where our biological forms cannot follow. The materials science that went into its construction, the engineering brilliance that guided its launch and trajectory, all of these represent an investment in a future far beyond our immediate comprehension. We can only imagine what future intelligences, if any, might one day encounter this emissary from Earth. They might not understand our languages, our cultures, or our motivations, but the sheer fact of its existence, its deliberate journey away from its home world, speaks volumes about the nature of its creators. It is a whisper from our past, traveling through the silent immensity of space and time, a testament to a species that sought to leave its mark, not just on its planet but on the cosmos itself. The Voyager probes are not just scientific instruments. They are time capsules, carrying not only data but the very essence of human ambition and our innate desire to connect with something larger than ourselves. Their enduring presence serves as a constant reminder that even in our transience, we can create things that ripple through time, leaving a trace of our existence in the grand, unfolding story of the universe. The sheer persistence of this machine, a fragile shell of metal and electronics against the backdrop of cosmic timescales, is a humbling and awe-inspiring thought. It underscores the potential for life, for consciousness to leave a lasting imprint, a legacy that can outlive the stars under which it was conceived. The knowledge that Voyager will continue its journey, long after humanity has perhaps faded or transformed, imbues its mission with a profound sense of purpose, a quiet defiance of oblivion. Voyager's silent drift through eternity offers a profound perspective on our own fleeting moments, reminding us that even the smallest act of creation can resonate across unimaginable stretches of time. Humanity's reach, a testament to ingenuity. The distant hum of Voyager 1, a whisper now, carries within it the echoes of human endeavor, a profound testament to our insatiable curiosity and our remarkable ingenuity. It is not merely a spacecraft. It is a symbol, a meticulously crafted vessel propelled by a constellation of brilliant minds and dedicated hands. Consider, for a moment, the sheer audacity of its conception. To conceive of a probe that could not only escape Earth's gravitational pull, but traverse the vast, unforgiving expanse to the very edge of our solar system, and then beyond, into the realm of interstellar space, is a feat that still inspires awe. This was not an accidental journey. It was a meticulously planned expedition, a multi-generational undertaking that required unprecedented levels of scientific understanding and engineering prowess. The intricate dance of gravitational assists, the precise calculations for trajectories that would span billions of miles, the development of robust systems capable of enduring the harsh vacuum and extreme temperatures of space for decades. All of these elements speak to a pinnacle of human achievement. The materials science that allowed its construction, the advanced electronics that power its instruments, the sophisticated communication systems that still, albeit faintly, connect it to us across the immense gulf. Each component represents a leap forward in our technological capabilities. It is a tangible expression of our innate drive to explore, to understand, and to push the boundaries of what is known. Voyager 1, in its silent, relentless journey, embodies the spirit of innovation that has characterized human progress throughout history. It reminds us that when we set our minds to a seemingly impossible task, driven by a shared vision and a collective will, we can achieve extraordinary things. This probe, a metallic seed planted by our species, is a testament to our capacity for creation, for problem-solving, and for reaching for the stars, even when those stars are unimaginably far away. It is a story of human brilliance etched in metal, and propelled by the very dreams that have always lifted us beyond our terrestrial confines. In the silent ballet of the cosmos, our reach, though fragile, is a testament to the boundless spirit of human invention, a quiet echo of our persistent quest to understand our place in the grand design. The quiet wonder of the cosmos, Voyager's silent song. Voyager 1, a solitary traveler, has transcended the familiar embrace of our solar system, venturing into the profound silence of the interstellar medium. This vast, cosmic ocean, largely empty yet teeming with unseen energies and ancient secrets, is where Voyager now navigates. It is a realm where the sun's influence wanes to an almost imperceptible whisper, and the true forces of the galaxy begin to assert their presence. Here, the very fabric of space is different, a tapestry woven from the remnants of exploded stars, the magnetic fields of distant nebulae, and the ceaseless, energetic dance of cosmic rays. Voyager's instruments, though aging, continue to gather data, painting a picture of an environment far more complex and dynamic than we could have imagined from our vantage point within the heliosphere. It is a testament to human ingenuity that we have placed an object, a fragile ambassador of our species, into this extreme frontier, allowing us to perceive, however faintly, the grander symphony of the universe. The information it sends back, traveling across unimaginable distances, is not just scientific data. It is a narrative of our place in the cosmos, a story written in the language of physics and born on the slow, steady pulse of radio waves. This journey, extending far beyond the lifespan of its creators, is a profound act of reaching out, of seeking understanding in the face of overwhelming scale. The interstellar medium, once a theoretical concept, is now a tangible landscape being explored by a small, persistent emissary from a pale blue dot. Voyager's persistent hum, a faint echo across the void, reminds us that even in the deepest quiet, there is a continuous, unfolding story of existence. The silence is not emptiness, but a different kind of fullness, a vastness that hums with the energy of creation and the echoes of cosmic history. As Voyager continues its silent song, it sings of the universe's grandeur, a lullaby for the cosmos that gently guides us towards a deeper understanding of our own small, yet significant, place within it. The sheer audacity of this mission, the relentless pursuit of knowledge across such immense distances, inspires a sense of quiet awe, a feeling that we are but a small part of something immeasurably vast and wondrous. And in this vast, quiet song, we find our own peace, a gentle reminder that even in our smallest moments, we are connected to the grandest cosmic ballet. Our calm exploration tonight has covered the extraordinary, almost unfathomable journey of Voyager 1, humanity's furthest reaching emissary. We have traced its silent launch, a whisper of intention from Earth, and followed its celestial dance, propelled by the gravitational ballet of gas giants. We have witnessed the awe-inspiring spectacle of Jupiter's storms and Saturn's shimmering rings, not as distant points of light, but as complex, dynamic worlds. We have ventured with Voyager into the enigmatic heliosphere, crossing its boundary to enter the interstellar medium, the true, profound void. We have considered the unseen messengers of cosmic rays, the symphony of charged particles, and the delicate dance of Voyager's compass as it navigates the galactic magnetic field. We have felt the fading whisper of the sun's influence, acknowledging the immense challenges of communication across such vast distances, a testament to the speed of light's inexorable tyranny. We have contemplated the deep freeze of interstellar space, the enduring power of its thermoelectric heart, and the tantalizing glimpse of the unknown that Voyager continues to provide. We have listened to the stories carried by cosmic rays, unraveling the history of our galaxy, and felt the gentle push of the interstellar wind as we left the heliosheath and the bow shock behind. We have reached the heliopause, the true exit from the sun's dominion, and considered our sun's place within the grand tapestry of the Milky Way. We have reflected on the search for exoplanets, gaining a unique perspective from the edge of our solar system, and contemplated the future of exploration, recognizing Voyager's enduring legacy. The Golden Record, a message of peace and hope, continues its silent voyage, a testament to humanity's ingenuity and our innate desire to reach out. Voyager 1 stands as a symbol of our quiet wonder, its enduring presence a gentle reminder of the vastness and mystery that surrounds us. As you drift, remember that your own existence, like Voyager's journey, is a part of this grand, unfolding cosmic narrative. You are a part of this immense, interconnected universe, and there is profound peace in that realization. It is time to rest now. Sleep well. Good night. If you happen to still be awake, you can drift into the next chapter now, where our quiet exploration continues.